Can you see my screen?
Yes, sir. Yes, sir.
Okay, the presentation first slide, right?
Yeah, correct, sir. Correct, sir.
Okay, yeah. So, very good morning to all of you. This is again Surinder Singh. For the persons who are new, I'm Surinder Singh, and I'm an assistant professor in the Department of Civil Engineering, Transportation Engineering Group, IIT Madras. And today I'll be talking on use of innovative materials in cement concrete pavements. So first of all, I would like to thank Dr. Amarendra for inviting me and conducting a very beautiful and systematic faculty developer program on cement concrete pavements. So I welcome you all. So, so we'll be starting in today's, the discussion. We'll be talking why we need the concrete pavements and how we can, recycle the concrete pavements, or what are the various innovative materials. So why? You can see whether it's Andhra or the other parts of the country, there is a ban on quarrying activities, right? So definitely, we need to explore the other pristine, other aggregates apart from the pristine aggregates that we are utilizing, right? So today's presentation will be on what are the various innovative materials and how we can utilize all the materials. Okay, not if you are not able to utilize in 100% proportion, how some proportion also we can utilize, but before that we need to study those materials. Okay, so starting the presentation. So what is need of rigid pavements? Okay, so actually I'll always take this example that we need concrete pavements, especially in the areas where there is a heavy rainfall, or we can say monsoon season, right? So if you can see here, this is a pavement which is in Kerala. It was a guest house payment. So I went there for a lecture in MA Engineering College in Kerala. So what I found that the roads were green. Okay, so you will be curious when you are going to Kerala that it's a very green state. It's so green that the roads were also green. So I zoomed those pictures. What I found that there is no bitumen or there is no asphalt in these pavements. And might be, because of the monsoon, there was a bitumen, but stripping of the bitumen might have happened, and the seeds from the near adjacent plants fell and then started growing within the pavement system. Okay, so this is a service lane. Okay, only few persons are utilizing it. Let's say if it is a case for the highway, or in fact say for the shoulders also, what will happen? In the one flow only, the entire pavement will be demolished, or you can say detroited. Okay, so from these pictures, what I can say that for the areas where you have high rainfalls or high monsoon season, which is most part of the country, it is the same scenario. So we should give preference to the cement concrete pavements. So there are other disadvantages also as far as the flexible pavements are concerned, and one of the lacunas is the potholes. Okay, you can see here that there is a big pothole. Actually, it happens because of many reasons. One of the primarily reason is the presence of the water, because bitumen and the water are like enemies to each other. When the water will be coming, bitumen will be running. Okay, so you can see that there will be many potholes will be available. Okay, for fishing, you can say fishing on a humorous manner. So the other distresses in the typical flexible pavements are the fatigue distresses. This happens because of heavy vehicle loading. So what happened during the peak harvesting season? So there will be overloading, and then the frequency of the traffic will also be higher. So combined effect, you can see the alligator cracking, because it resembles like an alligator. So we call as a alligator cracking. It's nothing but a fatigue cracking. That means that the pavement has been failed. Okay, so one of the other commonly seen distresses in case of the flexible pavement is the corrugation, which happens because of settlement of the underlying layers. So if this happens, if you see that if you're flowing on a highway and you're feeling like this, you'll be enjoying. Okay, but yeah, in some years, in these depressions, the water will be staggered, and then again potholes will be formed. So what we are generally doing, we are filling it with the profile corrective measures, but after some time, again it will take the shape of the underlying layers. So one way to address this issue is by completely removing the payment and then compact the subgrade, or the other ways. Also, rutting is a major distress that can be seen. It is also happening because of two reasons, where either all the vehicles are traveling on a single side, or if the shape, see, this is the shape of the normal rutting. So this shows that either the surface layer has not been compacted fully, or all the vehicles are moving on the same line. And if you see the position or the shape of the pavement like this, that means that this is rutting happening because of the poor compaction of the subgrade soil. So because of these reasons, we can say that flexible pavement is having lesser stability, lesser durability, especially in the areas with monsoon season. And because of that, after every monsoon season, whether it's Andhra, Tamil Nadu, whatever soil, because of the heavy rainfall, we need to repair it. So that's why there will be high maintenance cost involved. Okay. On the other hand, concrete pavements are having better durability and stability against monsoon, against heavy traffic loading. Okay, and we don't have to maintain this. Because of that, it's economical as compared to flexible pavements. And moreover, during the construction, it's environmentally sound also. Yeah, so see, rigid pavements are good, but yeah, there will be few disadvantages. The first disadvantage, because of which it was not popular, sorry, is the high initial construction cost, and especially developing countries like India, we are focusing on initial construction cost only. However, CRRA group did a research study, and they found that the choice of the pavement depends upon two major factors. One is the strength of the subgrade, other is the traffic loading. So if your strength of the subgrade is well enough and your traffic is lesser, then obviously a flexible pavement will be economical. On the other hand, you have poor subgrade and with heavy traffic, rigid pavements will always be economical. And if you can see in India, the subgrade quality is not good. If it is good also, our traffic has been increased exponentially. So that means rigid pavement may be the better choice, right? But can we wait for 28 days or at least for 14 days? No. The flexible pavement, we can use it just immediately after the construction. But concrete pavement, we have to wait for 14 days at least, preferably 28 days. So what to do? So that's why we can address these issues nowadays with the help of the precast pavements or roller compacted concrete pavements. Okay, like we discussed in the first lecture on Monday, we have the roller compacted concrete pavements which can be used just after its construction. So if you want to know more about the roller concrete pavement, there is one person in IIT Roorkee, Solomon Debarma, is working extensively on roller compacted concrete, or you can approach me for further details. So before talking about the innovative materials, because some of the students are also attending, we should know what are the normal materials or natural materials we have to use for formations of different layers of a concrete pavement. Obviously, we need the soil for the subgrade. We need the coarse aggregate and the fine aggregate for different layers of the pavement. And we need cement when you have to cast the wearing course, which is pavement quality concrete, or the base course, which is dry lining concrete. We need the cement. And nowadays, we have some advanced materials which can vary the properties or strengthen the properties of the concrete mixtures, such as we have chemical admixtures and we have mineral admixtures. In chemical admixtures, these are the chemicals which are used for improving the workability of a concrete mixture. If you want to accelerate the setting time, you can use it. If you have to retard it, you can do it. If you want to reduce the water by cement ratio without affecting the hydration characteristics or the workability, you can use the plasticizers. And nowadays we are having the mineral admixtures. Okay, and the mineral admixtures are used to improve the durability properties as well as the mechanical properties of the concrete mixtures, whether it's a silica fume, fly ash, and nowadays, if I talk about the Andhra, we have the rice ash gas, or if I talk about the northern part of the country, we have the bagash ash. So these are the agricultural or industrial waste which can be used to improve the properties of the concrete mixtures. It will not only reduce the economy, it will not only optimize the economy, but it will enhance the properties if used in optimized proportions. So you must be hearing this word always, sustainability, sustainable. So the book language says that sustainable means judicial utilization of any material or natural resources in such a manner that the future generation can use it. But as far as my definition is concerned, I'll say sustainability means we should not use the natural resources. We should always use the already utilized materials. That is 3 R's we have to do. We have to recycle, we have to reduce, and we have to reuse. So not ourselves, but our future generation should also recycle, reuse, and reduce the waste. Then only we can say it's sustainable approach. So what are the various materials that we can use for inducing the sustainability in the payments? Okay, if I talk about there are various materials like just in the previous slide we discussed about fly ash, silica fuel, rice husk. These are the sustainable materials. But in today's presentation, I'll be confining myself to the recycled aggregates only. Okay, there could be many recycled aggregates. Mostly, we can divide it into recycled concrete aggregates. That is the waste material we are getting after a building or after a existing payment, concrete payment is demolished because of any reason. We call them as recycled concrete aggregate. We have reclaimed asphalt payment, or popularly known as RAP, R-A-P. So these are the materials which are getting after a flexible payment is to be demolished because of all the distresses that we have discussed in the second slide. Nowadays we are having industrial aggregates like copper aggregates, slag aggregates, okay. And in fact, we are working on converting the fly ash into lightweight aggregates for building infrastructure. And nowadays, researchers have started working on the use of plastic aggregates and the rubber aggregates for the concrete mixes as well as the flexible payments. So in today's presentation, I'm sticking only because 1 hour you cannot finish all the things. So we'll be confining ourselves to recycled concrete aggregates and reclaimed asphalt pavement aggregates. So before that, we should know why we have to use these waste materials. Okay, and before that, when there is a situation that you don't have the natural materials, you have to use the recycled materials, then how to know whether these materials can be utilized or not, right? It's not that simply you're using waste materials, casting 1 cubical specimen, testing the composition, and you will say, oh, I can use it. No, it's not the right approach. So we here in IIT Madras, we sort of, we fundamentally study the material properties and then only decide this material can be used or not. So I have made one sequence. First of all, you have to mechanically characterize this waste material, right? And then chemically characterize this waste material. And then you have to check that this material, when used for concrete in different proportions, normally we use the proportions like 25, 50, 75, 100. Okay, so it can vary depending upon your blending, aggregate blending zones. Okay, but yeah, for time being, we can say we have to replace natural aggregates in different proportions, 25%, 50%, 75%, and 100%. And we have to test the concrete performance. Let's say for the PQC, if I talk about the required strength is 4.5 MPa, flexure strength at 20 days of the curing at the field conditions. So we'll be replacing natural aggregates in these proportions and seeing at which proportion we are getting this strength, right? And then we can recommend that strength. But before that, you have to mechanically and chemically characterize the materials. And also, it's not only the strength, there will be durability parameters that need to be met. Okay, so we'll be discussing one by one. So I hope all the researchers who are here will today get to know, okay, how to characterize a waste material for the payment application. So if I talk about the mechanical characterization, we have many different properties. So the most important property is the specific gravity and water absorption. Okay, because if you can recall, on Monday at 11 o'clock, we discussed about the mixed design fundamental. So specific gravity was affecting the proportion of aggregates, right? So obviously the recycled aggregates mostly are having lesser density than the natural aggregates, because recycled aggregates will be having some contaminants from the parental source. So obviously it will be reducing your specific gravity. So apart from that, we have to check the other properties. So one of the property is toughness. Okay, because for the payment, vehicle will be coming and there will be impact loading. Okay, so the aggregates if you are intending to use a recycle aggregate, it should have enough toughness. It should have enough resistance to impact loading. So how you can map it? It's a simple equipment known as impact measurement system. You can use it. Okay. I won't go into the mechanics of how this is happening, right? So, and the other thing is that when you are compacting your mixes, when you are compacting your material, right? So the rollers will be compacting it. So there will 8 to 10 rollers and 10 rollers. Okay, so there will be some crushing action. So when you are using some recycled aggregate, it should have enough resistance to that crushing. So you can capture the resistance to compression or the resistance to this effect. So you can do it aggregate crushing strength test. Okay, so most of the laboratories will be having this equipment. Then because the pavement, we should have the resistance to abrasion, because the vehicles will be coming and the vehicles will be coming with some sand, okay, and then it will be abrading your surface. So normally if you are using some aggregate and it is very prone to, or it can easily be abraded, then when you apply the brakes, there will be slipping, there will be skidding, there will be many things that may result into some of the crashes at the pavement. So we need to check the resistance to the abrasion. Also, nowadays, if you see, the aggregates are polished. Okay, if the aggregates are polished, and definitely the friction will be reducing, and it can lead to many of the accidents onto the highways. Right. So if you are using some natural aggregate, it should not be polished very easily. So it can be mapped with the help of accelerated polishing testing equipment. Then obviously the shape properties. So generally what we need angular aggregate, so that aggregate to aggregate interlocking will be very good. And we should not be having flaky particles, elongated particles. So we have to see whether the recycle aggregates that we are intending to use should not be having too much of flaky and the elongated particles, and obviously soundness. So this is the most important property when you are using the recycle aggregates after specific gravity, right? Because if I talk about any recycle aggregates, it will be having higher water absorption mostly. So the water, if the water having sulfate or magnesium or chloride ions, because of the high water absorption, they will be coming into the pavement. Okay, and then what will happen? It will interact with the aggregate, and then there will be some expansive reactions, and the aggregates will be failing. And if the aggregates are failing, the entire pavement will be failing. So we need to check these aggregates for the soundness. If your aggregate is able to, okay, if the mechanical characterization is saying that your aggregate is well enough, okay, lying within this stipulated recommendation limits of mode specification or any of the IS or the IRC specification, then only you have to utilize it for concrete mixes. Okay. If it is not, then we have to treat the aggregates or process the aggregates. We'll be discussing it in the detail. So let's assume that my recycle aggregate is satisfying most of the properties. Then I'll be using for concrete mixes. So first thing, don't go directly for the compressive strength. We have to see that how these materials will be affecting your workability, because workability have a direct relationship with the strength properties. If you can see here that at a constant water by cement ratio, you can have 3 strength values. Okay, you can have 3 strength values. This is why, because of the poor compaction. If you are using any waste material and let's say it is reducing your compaction, okay, or it is increasing your compaction energy, and if you are not able to compact it, the strength can be reduced even if you are using more cement content. So we have to capture those behavior. But yeah, luckily we are having all these mineral admixtures nowadays, chemical admixtures. We can play with the these concrete matrices by varying the doses of those chemical admixtures. Okay, and then if it is giving you the enough workability, then you have to test it for different properties. If you are intending to use it for the buildings in different elements, then you have to check different properties. It's not only the compressive strength with the help of the cubes, it can be different properties. As far as the pavements are concerned, we have compressive strength and the flexure strength. We are designing our mixes, we are designing the thickness of the pavements based upon the flexure strength. Okay, so what you have to do after aggregate is being tested for the mechanical properties and it's found to be adequate, then check for the initial workability, and after that, what you have to do, you have to replace the natural aggregates in different proportions, like we discussed 25, 50, 75, 100 for as an example, and check its workability properties, and then check for the flexure strength. And we discussed in the last session that as far as the flexure strength is concerned, if it is for the buildings, you should use 3-point bending test. But if you are using for the payments, you should always test the advocacy of the material or the advocacy of these proportions by using 4-point bending apparatus, because payments fails in pure bending. Okay, it doesn't fails in shear. So if you draw the shear force and bending moment diagram, it will be like this. There will be no shear failure. There should not be any shear failure. Okay, and after that, let's say if you're 50% of your proportion of the recycled aggregate that you are intending to use, it's giving you enough properties. You cannot recommend it, okay, because there could be many durability issues related to the recycled materials. Okay, so based upon the application area, we can divide the durability properties into different categories. As far as the payments are concerned, the resistance to absorption, okay, shrinkage characteristics, abrasion resistance are the most important thing. And if you want to use some recycled aggregates in the coastal areas, then the resistance to aggressive ions will be the one of the dominating parameters. So we'll be discussing one by one. So let's say if in a laboratory, if you don't have any equipment, what you can do. So all these durability issues, okay, could be mapped indirectly by knowing the porousness of your concrete. Okay, so what happens, let's say I'm using some recycled aggregates here in the concrete, and because of that there is porosity. So if there is a porosity, there are the voids, so what will happen? The groundwater or the surface water will be coming, it will be coming with chloride ions, it may come with sulfate ions, okay, it can come with different ions, and these will be reacting with the hydrated products, and then there will be durability issues. So if we have to see how much porousness will be there in case if you are using some recycled aggregates. So how you can do it? You have to make the concrete mixes, concrete specimens, and then you can dry it for around 24 to 48 hours, and then you measure the weight of that specimen soaked in water for around 48 hours, then capture how much of the water has been absorbed by knowing the difference in the dry weight and the absorbed weight. Okay, that can indirectly you can say that this is the total water absorption. And if the water absorption is higher, that means the chances of the durability issues will be higher. Also, if you are, see, in the case of the concrete pavement, it's not only the water from the top, it can be water from the subgrade also. And normally for the rural areas where we are constructing the pavement directly on the subgrade, because of the capillary action, it can absorb the water. For that, what you can do, you can make small specimens, paint it from the side so that water should not be absorbed from the sides, and don't paint the bottom surface. And you can map how much of the water has been absorbed. And obviously nowadays pervious concrete is being used for some applications, so you should know how much it is contributing or reducing the permeability. So if you want to know more about the pervious concrete, we have one person, Suryakant Sahu. Okay, he's working on the pervious concrete. He's a research scholar in IIT Roorkee. You can contact him. Okay. Then obviously, like for the Tamil Nadu or the other coastal regions, if you are using the recycled aggregates for the marine environment, for the marine environment, you can have the chloride ions, you can have the sulfate ions. It can go, and then you can see here the entire structure is being failed. Okay, so you have to know what is the right proportion of the recycled material that you have to use. Also, if you are intending to use for the structures, it can lead to the corrosion. So you have to see. As far as the payments are concerned, we have two distresses. One is plastic shrinkage, one is the drying shrinkage, and because of that, cracks will be there. It can be functional as well as the structural cracks. So that's why we have to characterize the waste material. We have to know what is the optimum proportion of the recycled aggregates that you have to use. And also the abrasion resistance. Like we discussed in the design fundamentals, that after making the payments, we are making some, some surface texturing so that it can provide you enough friction. So if you're using some waste material, especially the finer fractions, which in due course of the time will be, removed, then slipping, skidding, and then subsequently, some chances of the risk will be there. And if you are using some recycle aggregates for the areas where you can have, temperature as near to the 0 degrees Celsius, then the water will be going inside your pavement. In the night time, it will be freezing, and the frozen volume will be higher, and then it will exert some pressure onto the nearby structures or the concrete, and then the stress, because of these stresses, the crack will be developing. So you need to optimize the optimum proportion. So in a nutshell, what I can say you that if you want to use some recycle aggregates, it's not only the compressive strength, it should be the different properties based upon the application. Okay. So we'll take a case study on recycled concrete aggregates, which I'm presently working on. All my group is working on different recycled aggregates. One is the recycled concrete aggregate. Okay, so recycled concrete aggregates are the materials that we are getting after an existing infrastructure is demolished because of many reasons, whether it's an achieved service life, or nowadays you can see earlier we had only one floor or G+2 structures. Nowadays we are increasing the height of the structure, so we have to demolish because they are not designed to take that much of the load. Okay, so we are demolishing it. So in the right now, some of the figures says that in India we have 700 million tons of C&D waste, but these are the reported figures. We don't know how much is being generated. Okay, we did some study in Chennai. We found that in Chennai alone we have more than 100 million tons of the C&D waste. Okay, so if I take in account the entire country, then it could be much higher. Okay, so normally when you are demolishing a building, you will be getting around 23% of recycled concrete aggregate. And what is recycled concrete aggregate? It is the aggregate only. Okay, but with cement mortar paste from the previous building. Right? So can we use it? Because it's a significant proportion. So if you see that in India, how we are using the recycled concrete aggregates. So what we are doing, if you see that the concrete structures will be, big structures, right? Big chunks will be coming. So what we are doing at the site, only manual segregation will be done. We are removing the steel bars, we are removing the ceramic tiles, and then we'll be disposing it. Okay, we are not disposing the steel because steel, it's much expensive, right? So you can see that in all the C&D waste, they will be totally removing the steel because it is a high residual value. It can be resold, it can be refilled, it can be recycled. Okay, why can't we do with the recycled concrete aggregates? So generally what we are doing after manual sorting or the mechanical sorting we can do, and then we are crushing it into different sizes. Okay, we are crushing it into coarse aggregate, different sizes, and we are crushing into fine aggregates also. Right? So let's say in India we are getting 716 million tons of the C&D waste because of the sorting and because of poor processing. We are able to recycle only 60% of the materials. What about the remaining 40%? It will again go to the disposal areas. So can't we utilize it? Yeah, definitely you can utilize. It's a big proportion. But for that we have to fundamentally understand the material itself. So how to fundamentally understand? If you see here that it is a natural aggregate. It has a rough texture, it has a good interlocking capacity because if you can see the angular shape aggregates are there and the surface is clear. But if I talk about the recycled concrete aggregate, again, see here these are the natural aggregates only. But from the previous building, there will be some attached mortar. And this is the attached mortar because this attached mortar will be increasing your water absorption by around 4 to 5% because it's too porous in the nature. Right? And it will be reducing the mechanical performance of the aggregates. If you see here that this is a typical case study, I took it from the literature which says that the natural aggregates, we should have water absorption value of less than 2%, right? If you are intending to use for the concrete pavement application. But the recycled aggregate can have a value up to 12% because of this added mortar. And as far as the other premium properties of the aggregates are concerned, such as toughness or the crushing strength or the resistance to abrasion, normally we say that if you want to use some aggregates in PQC, it should be less than 30%, all these values. But for the recycled aggregate, this value can be way higher because of this added mortar. So what we did, we saw that one of the buildings near to our campus was being demolished. We brought it into our lab, crushed it as for the normal, crushing size synchronology that we are adopting. And then we found that we characterized it, all the fractions, the coarse aggregate fraction, 20 mm and 10 mm, and fine recycle aggregate. What we found that the specific gravity of these recycle aggregates was very much lesser. Normally, specific gravity should be nearby 2.6, but these are, low weight aggregates. Why? Because it will be having some motor. Okay, and this motor will make its weight little lesser, right? And as far as the water absorption is concerned, you can see it's varying from 4% to 10%. For fine aggregates, it's around 10% because this motor will be having more porousness because of this added motor. So the added motor may be, okay, it can be covering your entire aggregate, or some of the aggregates will be partially covered. It can be up to 42%. Okay. So what we did, we characterize it and we think, okay, we'll see what the specifications is saying. So these are the specifications which is followed across the globe. This says that if you want to use some recycle aggregate, its water absorption should be lesser and this density of the aggregate should be more. These are the two parameters which, with the help of which you can quantify the aggregates for the concrete infrastructure. Okay. So in most of the cases, it is less than 2, right? But this is for the globe. What about the India? In India, we have recently revised IS 383 specification in 2016. Now it allows us to use the recycle aggregates in different proportions. If you see here that for the lean concrete, that is where the strength requirement is less than M15, you can go with 100% recycling. Okay, you don't have to be afraid now because code specifies you to do it. If you're using for plain concrete, you can replace 25% of the natural aggregate by these recycled aggregate. Sorry. Then when you're using for reinforced structures, you have to reduce it by 5%. That means 20% of the pristine aggregates can be replaced by natural these recycled aggregates for reinforced concrete applications. Okay. What about the payments? Payments, we are using IRC 15. Okay. So IRC 15 says that you can use for dry link concrete. Dry link concrete requirement is M10. Okay, means 10 MPa strength. But there is a mismatch. For buildings, they are saying, because in buildings, you see there is a use factor, there is a risk factor. Because we will be staying in the buildings. Building collapse, what will happen, right? So this says that for a concrete of up to M15, that is 15 MPa strength, you can use 100% recycled aggregate. But for the dry link concrete, which is not a load-bearing layer, we can use only up to 30%. Okay, and it's strictly prohibited to use the final fraction. Why it is happening? So obviously this is happening because of the added motor. Because we don't want that the water from the adjoining area containing sulfate ions, chloride ions should come and then fail our payment. So I think as the researchers, we should work hard on this aspect, and we have to increase the proportion of the recycled aggregates because we don't have the natural aggregates right now because of the ban on the quarrying activities. So we have to increase this proportion by doing some fundamental study. Fundamental means you have to characterize the aggregates. Fundamentally, it's not like using the aggregates, making some concrete cubes and then saying that, yeah, we have achieved this strength, it can be used. No, it's wrong. So why? Because what is happening when you're using some recycled aggregates? Let's say if I use the recycled concrete aggregate, what will happen? Before that, we should know what is happening in the normal concrete mixture. This is an aggregate. This is the cement mortar paste. If you can recall from the mixed design fundamentals from the day one, the water nearby the aggregates will be higher as compared to the water in the concrete matrix. Because of the higher water, the water by cement ratio will be higher at the interface zone. And that's why the interfacial transition zone is the weakest link. So if you apply the loading, if your aggregate is good enough, if you are making M60 grade concrete, but the crack will be going through the interfacial transition zone. Okay, it will be failing in similar manner. So this is for the normal concrete. If I talk about the recycled concrete aggregate, this is the aggregate. Recycled concrete aggregate is having old mortar at some places. At some places there will not be any adult mortar. So there can be 3 interfacial transition zones. One interfacial transition zone between the new cement paste or new cement mortar and the old attached mortar. One interfacial transition zone is between aggregate and the old mortar, and one between the aggregate and new mortar. So obviously, this interfacial transition zone in most of the cases will be good enough. Okay, and this interfacial transition zone between the aggregate and old motor or the new motor and the old motor will be lesser. So if you apply the loading, the cracks may go from here or the cracks can go from here, the high chances, right? And it will be failing. So we have to address this interfacial transition zone. Like we discussed here, that when you apply the loading, the crack can go from the new motor, which is desirable. The crack can go from the old motor and new motor. The crack can go propagate through the old motor. It can go from the interfacial transition on between the old motor and aggregate, and it can go from the aggregate. And you know, aggregate as the most strongest component. If my crack is going from the aggregate, that means I will be on the safer side. But in most of the cases, it is going either from, it is following either failure mode 3 or failure mode 4. That means this old motor, we have to address it. So how to address it? We have to study. So we fundamentally studied those, old motor, because we know we use more portion of the cement or whatever we do, the crack is going through the old motor. So what to do? We thought, first of all, we have to read. We have to study this old motor. What we did, we put some thermocouples, okay, and then we put in the oven at different elevated temperatures, and what we found that at around 500 degrees Celsius, okay, and if I keep into the oven, then the hydration products were dissolved, and when the hydration products are dissolved, this motor will be, very weak because of the heating, because of the, variation in the heating. There will be temperature gradient, and then the only thing you have to do, you have to scratch it away. So how to scratch it away? We kept in a ball milling machine, and then we rotate it, and then we could separate the motor from the aggregates completely. Okay, you can see here, this was the recycled aggregates, and then after processing it, you can see the clear aggregate picture is visible. Okay, and as far as the characterization is concerned, earlier the specific gravity was less than 2.4, now the specific gravity is more than 2.7. Okay, and earlier the motor content was 42%, now it's 3% only. And then we thought, now we'll be using these recycled aggregates for all grade. Okay, we saw the workability. So for the PQC, you need a workability of 25. Okay, it was achieving it. As far as the compressive strength is concerned, in fact, at 100% proportion of these, we were getting a strength of more than M40. That means 100% of these recycled aggregates could be used for pavement quality or grade. Okay, so what is the Indian scenario now? If I see, I told you, right, there is a ban on the quarrying activities, especially the fine aggregates, right? And if I talk about the aggregates, let's say limestone aggregate, if I keep the production of the cement and the consumption of the cement, the rate as constant, in next 40 to 50 years, will be exploiting all our natural resources. We will not be having any recycled aggregates, because most of these quarries are now under the natural forest, where we cannot extract it. So what we have to do? We should use the recycled aggregates, right? But after using the recycled aggregates also, we have to explore for other aggregates, because the requirement is too higher. Okay, you can see the total demand per annum is 1.6 billion tons. And how much recycled aggregates we are getting? 700 million tons. Okay, what about the remaining fraction? We have to explore the other materials. As far as the highway is concerned, we have explored. See, in highways we have different layers, right? We have discussed. We have granular subbase, we can have waterbound, macadam, WLM. Okay, we have the binder course in flexible pavement, we have the bearing course. So, if I see these layers, here we are using the aggregates, right? And if you remove it, you will get a normal aggregate, new aggregate. You can crush it also, because the size of the aggregate in these layers is higher. And these are the natural aggregates only. Okay, so we did some analysis for entire India considering the worst scenario and the good scenario. What we found that if you are replacing the existing flexible pavement to concrete pavement, then we'll be getting around 28 billion tons of coarse aggregate and 9 billion tons of the fine aggregate, which is enough to convert the existing flexible pavement into concrete pavement across the country. Okay, but what about these two layers? Okay, because these aggregates are known as RAP aggregates. Yeah, obviously there will be some problem. Okay, so starting with what is this RAP? RAP is nothing but when the flexible pavement is to be dismantled, because of any reason, mostly because of the distresses. So the aggregates will be getting are known as RAP aggregates. Okay, so now like for GSB, if you extract some aggregate, it will be natural aggregate only. But from the surface course or the binder course, you are extracting the aggregates, it will be having some bitumen coating. And then I'm saying that we can use the RAP aggregates for concrete pavement. And if there are some practitioner engineers, okay, most of you are the teachers or the research scholars or the students, you should not use any aggregate. In fact, having a coating of dust also, you have to wash those aggregates. Now you'll be saying this is a mad person. He's saying we cannot use any aggregate having a dust coating, and how he's saying that we can use the RAP aggregates which will be having a bitumen coating, organic bitumen coating. That's also for the concrete pavements. Okay, so we can do it, but we have to fundamentally characterize it. So we studied the RAP aggregates. We found that they could have many different layers of the contaminant layers. Mostly it will be having agglomerated particles and bitumen. Okay, so agglomerated particles are nothing. You see here, they are the two aggregates sticking with each other, or the small size aggregates are sticking on the periphery of the coastal aggregate in presence of the bitumen. So obviously, if two aggregates are sticking with each other, with bitumen, not with the cement, so you can easily detach it. But it's very difficult to detach single particles. So when you are using for concrete mixes, so your properties will be reducing. Obviously, if you have bitumen, so bitumen, what the bitumen will do? Bitumen will hinder in the bonding of cement paste with the aggregate surface. And the bonding that will be developed between the cement mortar paste and the bitumen, being too poor in the nature, will tend to reduce your property. That's why we should not use these RAP aggregates. As far as the final RAP aggregates are concerned, because the finer fraction are already sticking around the coastal fraction, right? So obviously the fine aggregates will be highly gap graded in the nature. Mostly with my analysis, what I found that the fine aggregates, the percentage passing through 600 micrometer, this is very much required when you are talking about the the mixes for concrete pavements, because we have to consider the thixotropy. So these will be affecting the potential of a mixture to be used with the help of the paver machines. So we thought, okay, anyway, we'll adopt our normal procedure, that is, we'll be characterizing the aggregates mechanically, and then we'll later on see for the concrete mixes. So we were, some interesting results were found. Okay, so see, specific gravity, this is for the natural aggregates that we have considered. It was 2.65. For RAP aggregates, it was 2.39. Okay, it is well enough. Water absorption was also less than 2%. Okay, that means as per the specification, I can use it. Impact value, crushing value, low surface abrasion value were all lesser than the natural aggregates. Why? Because if you are using the normal procedures, so when you compact it or heat it, then the bitumen is soft. It will bind the aggregates into single mass. So obviously the amount of the waste or the difference in the mass, you cannot map it because you are not able to crush it. Okay. So with the help of the mechanical properties, it shows that we can use these RAP aggregates for pavement application, but I will disagree here because all these normal, you see here, this is the flakiness. Okay, because these are the agglomerated particles. Aggregates will not be flaky. Okay, and the elongation value, will be higher. That means these normal procedures could not be used for characterizing this kind of waste material. You have to, innovate some other methodology or improvise these methodologies. Okay, so similarly for the fine aggregates, what we found that it was gap graded in the nature. So we thought, okay, we cannot use these aggregates right now. Okay, but can we use it for the drying concrete? Okay, drying concrete is not a load-bearing layer. Okay, it provides the support for the construction of the PQC. So can we use it? We thought, okay, let's try to use it. Okay, so what we did, before that you should know about the drying concrete that we discussed in first presentation. It's a lean concrete, zero slump mixture, which is used for base course of the concrete pavements. So what we did, we replaced the natural aggregates in different proportions, 25%, 50%, 75%, 100%. Okay, both the coastal fraction as well as the final fraction. What we see that there was a significant reduction in the dry density of the mixes when you keep on increasing the proportion of RAP aggregates. And as far as the fine aggregates were concerned, a significant reduction in the MDD value was absorbed. And you can see here the aggregates were, the mixture was having significant segregation and bleeding. This has happened because the bitumen. Bitumen is a hydrophilic in the nature, right? It will not absorb the water. So the chances of segregation will be higher, and because the fine aggregates are gap graded in the nature, obviously segregation and bleeding are inevitable. Okay, and the attribution for lower dry density or the MDD value for the DLC mixes with increased dry proportion is because bitumen specific gravity is 1, aggregate specific gravity is 2.7. If you club both, the combined specific gravity will be lesser, and hence the lesser MDD value. So we thought, okay, we'll see how it is affecting our compressive strength, because DLC is designed based upon the compressive strength. So you can see here that this requirement is 7 MPa, was 7 MPa when I did this analysis, now it's 10 MPa. The natural aggregates at 7 days, it reached 14 MPa strength. But if you see here that when we replace 25% by the RAP aggregate, the strength reduces by more than 50%. And if I talk about the other mixes, none of the mixes achieved 7 MPa strength criteria. In fact, the higher mixes didn't achieve the 7 MPa strength criteria 20 days of the curing also. Okay, so what is the attribution? Obviously, the attribution that we discussed, the agglomerated particles are there, the bitumen coating will be there, fine aggregates are poorly graded in the nature, and obviously there is a relationship between the dry density of the DLC and the strength. If you are getting a lower dry density, that means its properties will also be lesser. Okay, so why this is happening? Then you go to know that who are the major culprits? The major culprit is the bitumen film or the other contaminant layer and the agglomerated particles. Can't we remove it? Okay, can't we remove the agglomerated particles? Or can't we, just provide some windows from which the cement paste will be going and interacting with the aggregate surface if you are not able to remove it? Yes, you can do it. Okay, these are the organic compounds. They are totally soluble in toluene, or you can say benzene, kerosene, diesel. Okay, you can do it. But is it feasible? It is sustainable? No, it is not sustainable. So what we have to do? Right. So we thought, okay, we cannot use all these chemical admixtures or chemical solvents. What we should do? So we studied it. What we found that there is a property known as oxidation. Bitumen is a hydrocarbon in nature. When it's exposed to the ambient environment, so what will happen? The aromatic compounds will be oxidized, and then bitumen fraction will be become brittle in the nature. And when something is brittle, by providing mechanical stresses over its surface, it can be broken. So what we did, we extracted the flexible pavement material, okay, crushed it at the field, and then stockpile into the open environment for around 6 to 8 months, so that oxidation could be accelerated. So now see, earlier it was black color, then it was brown color. Brown color because we stockpile into the open form. Okay, that's why soil might have mixed with it. And then what we did, because now this bitumen is stiffer in the nature, we put it into the ball mixture. Okay, and then for providing the mechanical stresses, we put some steel balls and then allow it to rotate for about 15 to 20 minutes. So normally you can use the normal mixtures also. Okay, so you have to keep 25 kg of these RAP aggregates, and you can keep around 10 to 15 number of charging balls, just like low senseless abrasion machine. Okay, and then allow it to rotate. So we optimize it. I did these trials for around 6 to 8 months. Okay, with various proportions, various iterations, and then we optimized this technology. Actually, we innovated this technology, and then what you can see here, this is the RAP aggregates, and this is the RAP aggregates after processing. Okay, you can see the clear picture. So with this technology, I could reduce the bitumen content by around 50%. I could reduce the agglomerated particles by more than 70%. And then I thought I'm utilizing it for concrete pavements. Okay. So what I did, see, you'll be saying you did something in the laboratory and then you removed the bitumen. How you can generalize your findings? So we thought we were well aware about these questions. So we thought we will not be doing any verification. We'll be just going to the site. Okay, and we're utilizing the wrap aggregates, we'll be crushing it in the by manually only, because if you're crushing it by manually, the agglomerated particles will be higher, right? So it's a worst scenario. If you can make some concrete for the worst scenario, definitely it can be suggested for the good scenario. Okay, so we went to the field, we removed the existing pavement manually, we processed the aggregates manually, and then we used it for both the layers, drying concrete as well as the pavement quality concrete. And what we found, see, existing payment was there, we removed it, and then these are the steps that we have followed, and we measure the temperature differential as well. Okay, because you know, like we in the design fundamentals we discussed, so the loading on the payments is not because of the vehicle, it will be also because of the curling or the warping. So you have to measure the curling as well. I think somebody has to mute. Okay, someone is unmute. Please mute yourself. Yeah, thank you. So because in the payments, there is the stresses will be occurring not because of only the load, because of the temperature also, right? So we monitor the payment for temperature differential. So you can see here that this is a natural payment, natural aggregate payment. This is a RAP payment. Look wise, both were same. Strength wise, DLC achieved 10 MPa strength. Okay, and the natural payment achieved 11 MPa, means the strength is both same. And here you should remember we have utilized 100% RAP aggregates. As far as the payment quality concrete is concerned, the compressive strength criteria was not achieved. The compressive strength requirement is 40 MPa, but flexure strength requirement is 4.5, and for RAP concrete it was way higher than 4.5. Okay, but yeah, if you compare with the natural payment, it's lesser. Okay, so like you know, we discussed, we designed the payment for fatigue analysis, right? We have to do the fatigue analysis. In fatigue analysis, we have the stresses because of the loading as well as the temperature. So we map the temperature throughout the year, and then what we found that the temperature differential in RAP payment is lesser than the natural payment. Okay, by around 2 degrees Celsius. And if you see these models, okay, provided by the ISC 58, the stress is directly proportional to the wheel loading as well as the temperature differential. So because of the RAP, if the temperature differential is lesser, that means the stresses will also be lesser, and subsequently fatigue damage will also be lesser. If you can see here, that total stresses on the natural slab was 1.89, for the RAP slab it was again 1.89 for the daytime, and at the night time it was lesser. So this shows that despite lesser strength, the stresses on the payments will be lesser if you are using RAP aggregates. Okay, and remember we did it for the worst scenario. Okay, so this was my last slide, and thank you for attending this thing. This is my group here at IIT Madras. We have many persons who are working on different aspects of the waste. We have Professor Ravindra Gittu. He is the Dean Research. Also, we have one Society for the Concrete, RILAM. So he is the first person from India who is the president of the RILAM Society. We have Professor Manu Santanam. He is the current HOD. Okay, we have Professor K.N. Satyanarayan. He works on life cycle assessment. He is the current director of IIT Tirupati. We have Professor Veera Raghavan. You must be reading Justu Khanna Veera Raghavan book. He is the author of Justu Khanna Veera Raghavan book. Okay, we have Professor K. Ramamurthy. Okay, he works on the fly ash-based aggregates. We have Professor Pillai. He works on a durability aspects. We have Professor Piyush. Okay, he's working on biomass or the agricultural waste as a for concrete mixes as a filler material or the secondary supplementary cementation material. And myself, I'm working on recycled aggregates. So with this, I would like to say thank you, and I would like to acknowledge Suryakant, who is the PhD scholar in IIT Roorkee. Okay, he's a very good person. He's my colleague. He's working on different aspects of the RAP material. So thank you. Now I'm open for the question and answer round.
Sir, thank you very much, sir. Actually, we are really grateful to have, sir. You have agreed to engage three sessions, and I must.
Okay, I can. You are on mute, Dr. Amrendra. You are on mute. Yeah.
Sorry, sir. Sir, I must say that our participant definitely have gained significant knowledge with your lectures, sir. And I request you to go through some of the questions are there in chat box, sir. Please go through that one, and then afterwards we provide conclusive remarks.
Okay, I'll take. So it's from
10:31, sir.
10:31.
Sorry. So Bhavna Rao, IRC 15 stipulates 3-point loading for finding the flexure strength of beam specimen. I don't think so. IRC 15 stipulates. Okay, if you are well sure, then I can cross check it. But we have for flexure strength or payment, we have to use 4-point bending only. Okay, maybe there is a slight misunderstanding here. We can say 2-point bending or 3-point bending. Okay, again, so that means we have to provide the bending at different locations. It's same only. Okay, so you can say mid-span bending or the 1/3 span bending. So, okay, in that case, it is ruled. Then, Kumar, what would be the cost of recycling aggregates per cubic? See, normally it depends. Nowadays, it's obviously it will be lesser because the recycling aggregates are available free of the cost. But because of many GSTs and the other things, and the transportation cost, okay, nowadays it is equal. But we should not look for the cost. We have to look for the sustainability aspect. We are not having the natural aggregates. Okay, so we have to think in a greater picture. Our vision should be good. So obviously the cost wise, it is mostly equal, but on a slightly lower side. The Venkat Narayan, admixtures are really recent innovative. Any feedback on admixtures effect in the long run of the concrete? See, admixtures are the recent innovations. Yeah, I agree with you. But if I talk about some recent advancements, plasticizers, super plasticizers are using for the last 10 years. Okay, so yeah, see, we have the studies available. There is no negative effect of these admixtures on the long run. If I talk about the mineral admixtures, we have to see the chemistry. Okay, so what is doing? They are having the amorphous silica, which is reacting with calcium hydroxide, converting it to CSH gel. In the long run also, it's good, I can say. And why doing mixed design? How to decide, consider a percentage recycle aggregate in the see. Normally, what the people are doing, we have the blending curve. Okay, as per the MOS specification or the IC specification, you can use as much as you require. Okay, but mostly we are doing 20%, 50%, or 100%. But in order to, it's a very good question. Okay, or you can. The first thing, if you are a field engineer, use the blending curves. If you are a researcher, you can use some models to predict what should be the optimum proportion we can use and then do the laboratory trials. Okay, so it's known as packing density approach. You can search it. Dr. S.K. Rao, can we use 100% of recycled concrete aggregates and flexible pavement base course and sub-base course? Hey, why to use it for the flexible pavement? Yeah, okay, because it will be having porousness, it will absorb the bitumen. But if you are rightly speaking about the base case and the sub-base course, I cannot recommend, okay, because I'm not a flexible payment guy, I'm a concrete payment guy, but we have to stick to the IS specifications, which says that up to 30% you can use it. Then Govardhan, what are the various methods of removing the added mortars from aggregate and which method is efficient? See, there are many methods. If you go through the chemistry of these mortar, okay, what is the mortar? It's calcium silicate hydrate, calcium hydroxide, calcium carbonate, and some of the etringite. Okay, so obviously you have to study that. Right. So how these hydrated products can be dissolved? So one of the method is thermomechanical beneficiation. Okay, wherein you are using only heating the aggregates. Because if I can also recommend some chemical admixtures. You have to use some acid solutions. Which can remove this mortar, but it may affect the durability properties. So you can use any of the method, but you have to characterize the material before and after doing this treatment. So, Tizu Sushen Thomas, sir, how can we do the crushing of CNT waste effectively? Okay, we can use normal crusher. Generally, what happens? We are having two stages of crushing, primary and secondary. Primary crushing, you can go with the jaw crusher, and in the secondary crushing, you can go with the impact crusher. Mostly horizontal impact crusher, if you are utilizing it, then we have established some recycling centers here. We are following these two approaches, and we are getting good quality recycled aggregates. Then SB, does fly ash alone react with water and produce it? No. See, what is fly ash? You have to see. Fly ash is, having amorphous silica. So any waste material that is giving you the amorphous silica, it will be reacting with calcium hydroxide to form the CHS. Then Govardhan, do we have any recycling plant of course aggregate and treated recycle aggregate readily available? See, we don't have it for the treated recycle aggregates. Okay, it's in the research concept right now. Okay, research zone only, but we have around 10 to 11 recycling plants in India. Okay, then okay, Sastri sir, thank you for appreciating. So I think these were the questions, and you can mail me if you have any doubts.
Yeah, thank you, sir. Participants, suppose if you have any doubts in the future also, you can talk to sir, because sir has done significant work on recycling, especially if you can see in case of the flexible payment. So nowadays, a lot of waste material like recycled material is available. People are afraid to use as recycled materials, even in case of the base courses, surface courses, due to mainly lack of experience and experimentation for knowledge in that. So you can talk to sir. They have done good open report. I have gone through some of your papers also, sir, that you have published in IIT Roorkee, your page, right? So very good, significant contributions have done in the areas of research.
See, you can see right now. Sorry to interrupt you. Now I am the editor of this journal, Frontiers in Built Environment, and we have proposed one special issue there. Okay, so use of organic waste means these RAP aggregates for cement concrete matrices. Okay, if you want to publish it, definitely I will be happy. Okay, if somebody of you, of anyone, please start working on these RAP materials for concrete mixes, and you can submit your papers in that journal. It's Frontiers in Built Environment, and we have special issue. Okay, on organic waste.
Even I could have some doubts, sir. Definitely, I'll talk to you later, and I'll mail you, sir.
Oh, sure. I'll be happy.
Thank you, sir. Thank you once again for your wonderful presentation, sir. And also, on behalf of RGUKT and Civil Department, I say special thanks, because when I asked you immediately, you have accepted to deliver 3 lectures, because I thought of to give you the fundamentals or fundamentals of rigid payment. Then you said you want to deliver even this one also. I was extremely happy at that time, because I was a little bit like hesitate to ask you to deliver. Is it possible or not like that? But you yourself told me. Good, sir. Thank you, sir.
Thank you very much. Okay.
Keep in touch, sir.
Okay. Thank you very much.
I request my colleague, Mr. Chaitanya, to provide closing remarks.
Good morning, participants. Myself Chaitanya, Assistant Professor in Department of Civil Engineering.
Good morning.
RGUKT. Good morning, sir. Sir has started the presentation with an overview on advantages and disadvantages of rigid payment. Later then, sir explained the process of selection of different materials for any modification process. So then he elaborated the different steps in that process, like chemical characterization, mechanical performance, and then checking the performance with that selected material. So further, sir take a case study on recycled aggregates within the campus of IIT Madras. Then he elaborated the Indian scenario in concrete recycling. So in the final stage of his presentation, sir presented a case study on RAP and explained the technical specification and the different steps involved in the design. Sir, really introduced a new topic to us, sir, and I hope all the audience are benefited with your presentation. Thank you, sir. Thanks you once again.
Actually, I have one more suggestion. See, this RAP material, because it's hydrophilic in nature, I think it can be used for pervious concrete. Okay, so it will be very good thing if you are using for the pervious concrete. And since you are from the Andhra, it's a developed state, I can say. Because I stayed there for 5 years. I did my schooling from there. So for the high-tech city or those areas, we can use the pervious concrete, and then we can especially use the reclaimed asphalt pavement. Okay, so I'm not working on it, but it's a good topic. And like I said, one of the scholar, Suryakant, he's working on this use of RAP for pervious concrete. So he's a brilliant researcher in IIT Roorkee, and you can definitely send him email. Okay, so he'll be happy to take your questions also if you have any doubts.
Okay, sir. We'll definitely discuss with the issue with Professor Krishna Biligiri, sir, who is an expert in that pervious concrete.
See, this Suryakant Sahu, he did his master's work with Biligiri only.
Oh, sir. Okay.
Yeah. Right. He works extensively on pervious concrete. He started pervious concrete in India.
Yes.
Yeah.
So we have actually invited professors who are expert in different areas.
Yeah, so he's the first person for, who did work on pervious content in India. I am the first person who started working on recycling the, wrap materials for payment. So yeah, see, Dr. Amrendra, he's having, good jugaads, I can say, good links. Okay, he knows all the, that's why I call him Dr. Amrendra Bahubali. Okay, he knows all the big shots in India.
Thank you, sir.
Actually, I worked in the industry for 8 years. That's why you know me, sir.
Okay. Yeah, thank you, Amrendra, for inviting me. Okay.
Oh, I'll be in touch with you.
Yeah, sure. Okay, then bye.
వచ్చేసాడా participants, we will start next session. Sir, good morning, sir. Bhavanarao, sir. Good morning, sir.
Good morning.
Sir, how are you, sir?
Fine.
Sir, shall we start the session, sir, or shall we wait for?
We can start because time is short. Time given is short. We can make
okay,
up from that.
Okay, sir. We will start the session, sir. Participant, let me introduce Engineer D.B. Bhavanarao garu. Sir did his B.Tech in Civil Engineering, M.Tech in Soil Mechanics and Foundation Engineering, and PG Diploma in Alternate Dispute Resolution. Sir is fellow of Institute of Engineers. Experience. Sir worked in different cadres from Assistant Executive Engineer to Chief Engineer R&B department for 33 years and retired as Chief Engineer R&B in July 2010. So worked as a consultant for 7.5 years for Aegis India Consulting Engineers Private Limited. During this tenure, worked for 7 years as team leader, a project manager of third-party quality audit in the World Bank assisted National Cyclone Risk Mitigation Project in the 9 coastal districts of Andhra Pradesh. This project includes construction of roads, bridges, and buildings. Also worked as advisor, roads and bridges for 1 year in Amaravati Development Corporation, Vijayawada for Government of Andhra Pradesh. As Executive Engineer R&B Quality Control, he studied the regions of premature damage of several roads and found out that using red earth in GSP and WMM in roads is the main cause for early damage of roads. His article on adverse effects of using natural gravel in subways, base, and waterborne macadam was published in the monthly IRC magazine Indian Highways in the month of February 2005. Educated the department engineers by conducting several workshops and ensured the stopping the use of red earth in GSP and WBM in road works. It improved the performance of roads and saved huge amount to the government departments. Another article on steps to improve roads and black cotton soils was published in September 2007 issue of New Building Materials and Construction World, NBM and CW. So from the year 2000, giving presentations on how to construct durable roads, buildings, and bridges to field engineers. Organized several one-day workshops throughout the Andhra Pradesh for all the department field engineers to bring quality awareness among practicing engineers. Prepared handbook on highway engineers, which is useful for all field engineers. He is regularly giving expert lectures to field engineers of RNP, Panchayati Raj, PH, Singareni Collieries, AP Housing, AP CRDA, Amaravati Development Corporation, and other departments. helped in resolving the launch and problems at Indian Space Research Organization, Sriharikota in 2009. So we have really an eminent personality in the areas who is having expertise in all the areas, I can say. So since Sir worked in roads and building department, he has expertise in roads, he has expertise in structures like bridges and all. And I know Sir since several years, but I have not interacted Sir. So, but SAR articles, I have followed the SAR articles. Even some of the cases also has provided shortcuts to many field engineers how to use the using the MORPH and other Indian Road Congress specifications. We are really fortunate to have SAR today. So I request all the participants to make use of this lecture. And if you have any doubts, because like we have also since last four days, we're discussing many topics. Even if you have any doubts related to that topic also, you can ask Sir. He's happy to provide the like answers. Sir, please go ahead with your sessions.
My screen is sharing.
Yes, sir. Yes, sir. Yes, sir. I could able to see your screen, sir. No problem.
Okay. Thank you, Amarendra. Good morning, everybody. Yes, this presentation is on the construction and quality control of rigid payments. Actually, this presentation is prepared based on IRC 58, IRC 15, and IRC SP 62. Because IRC 15 deals with IRC 58 and 15 deals with high volume roads, whereas SP 62 deals with low volume roads. Because both are necessary required, I prepared the presentation using both the codes. The related codes are IRC 58, it is for design, IRC 15 for construction, IRC 44 for design of concrete mixes. It is for PQC. For DLC, we have to use IRC SP 49, IRC SP 76. IRC SP 76 is for white copy. IRC 57 is for ceiling joints. SP 62 for low volume roads. And this IRC SP 83, this is also very important because it covers all the rehabilitation items. Yesterday, Ramchandra has shown some stitching, etc. All these items are included in this IRC SP 83. For any repairs, any cracks, etc., we can refer this IRC SP 83. Now, this IRC 58 is applicable for roads having a commercial traffic more than 450. If the commercial vehicle traffic is less than 450, we have to follow SP 62. But for low volume roads, if we adopt IRC 58, it is not economical. If we go for IRC 58, it becomes a costlier. That's why for roads not having high volume of traffic, it is always better to go for IRC SP 62. These are the temperature differentials given in the IRC 58. In AP and Telangana, etc., comes under Zone 3. For Zone 3, if the thickness is more than 150, difference is 17.3, like that. Now, the problems for this cracking, etc., is mainly due to curling and warping. Curling is due to temperature differential, warping is due to moisture difference. If it is cool weather, the curling will be like this. In hot weather, the curling is like this. In wet weather, the warping is like this. And in dry weather, the warping is like this. In hot days, the curling, temperature curling is countered by moisture warping. It reduces the stresses. But during cool nights, the temperature curling is complemented by moisture warping. It becomes critical. These are the, this is already, the slides are already shown. Now, coming to the concrete strength requirement, the flexural strength is the main rolling criteria for concrete strength for rigid pavements. We require 3.8 MPa for low volume roads, whereas we require 4.5 MPa for high volume roads. For low volume roads, we can provide M30 concrete. For high volume roads, minimum concrete grade is M40. But some areas they are adopting M35. But M35 is not suitable for this high volume roads. This is the conversion factor. We can find out. We can also find out flexural strength by beams, conducting beam tests on beams. M30 gives about 3.83 MPa, whereas M35 gives 4.14 MPa, and M40 is giving around 4.43 MPa. Suppose if we adopt M35 concrete, it is not satisfying the requirement of 4.5 MPa. That's why minimum grade of concrete to be adopted is M40. This is the conversion factor of converting compressive strength into flexural strength. It is for we get approximate value, actual values we have to obtain from conducting tests and beams. This is to find out the chart to find out the subgrades, effective subgrade CBR, considering the bottom 500 mm layer also. This is the typical cross section of the rigid pavement. This is bottom is all embankment. The top 500 mm will it is likely to receive some stresses. That's why IRC recommends subgrade CBR and the CBR in the top 500 mm of embankment. Both are to be considered and find out the effective subgrade CBR for both the layers combined. The K value, effective subgrade K value, we can get from the graphs shown earlier, from the 500 mm thick subgrade CBR and the 500 mm thick embankment top layer CBR. For high volume roads, subgrade thickness is 500 mm. For low volume roads, the subgrade thickness is considered to be 300 mm because the loads are less, the stress is likely to be not penetrated up to the under thickness. Now, what is the first proposal? Granular subbase as separation or filtration layer. And next is granular subbase layer as drainage layer. This is, we require a minimum 100 mm thick for each layers. More than 100 mm is not economical also. But if we are not going to provide two separate layers, then we have to provide minimum 150 mm single layer. That is stipulated in the IRC. This separation layer is very dense layer with less voids. This drainage layer is having more voids. In most of all the expressways, national highways, etc., they are providing these granular subbase layers for full width. These two layers are to be provided for the full width of the formation. But citing cost criteria in many of the taken up by R&B department, etc., they are not providing this GSP for full width because of the cost limitations. They are adopting these things for national highways and other major projects. Next is dry lane concrete. For high volume roads, we have to provide a minimum 150 mm thickness. This is the pavement quality concrete. These are the shoulders. Shoulders and subgrade, we have to provide the same type of soils. Now, the ARC 15 gave two types of proposals for fixed rigid payments. Here they have provided drainage layer. On top of it, dry line concrete. Dry line concrete above 150 mm thick separation membrane. This is a plastic sheet having about 150 mm thickness. Alternately, we can provide 4 mm thick non-woven geotextile also as a separation membrane. Also, we can also provide geocomposite layer instead of this separation layer. If geocomposite layer is proposed as separation layer, we have to provide drainage layer of 150 mm thick, because it is this geocomposite layer is not supposed to act as a drainage layer. It is supposed to act as a separation or filter layer. That's why ARC recommends 150 mm thick drainage layer if geocomposite layer is provided for separation layer. Also, instead of DLC, cement treated aggregates layer is also given, which means that it is a CTSB. It is similar to cement treated subbase of same requirements. We require dry line concrete as per IRC 15, 7-day strength of 7 MPa. 7-day strength of 7 MPa means it is likely to get M10 concrete at 28 days. CTSB also gives a strength of 7-day strength of 7 MPa. That's why if we want to replace this dry line concrete with CTSB, then we have to provide a separation layer of bituminous concrete that is recommended in the IRC 15. Now coming to the rigid pavement class as per as IRC SP 62. The reference is here, the subgrade thickness is 300 mm and there is no full width to GSB or anything. Only GSB one layer, 100 mm GSB layer, and this is WM 70, the WVM 75 mm or 150 mm depending on the traffic intensity. That's why you can see from the two cross sections that it is IRC cross section proposal related to IRC 15 is very costly, and for traffic not having less than 450 commercial vehicles per day, it is not at all economical to go for IRC 58 or this IRC 58 and 15. It is always better to economical to go for IRC SP 62. And particularly for R&B department, they are having several low volume roads, but they are always insisting on proposing IRC 58. If they adopt, they can execute the more length of roads with the same amount. These are the conversions factors from the CVAR of subgrade. If the effective K values can be found out for GSB and this cement treated base, sub-base and base, and also for dry line concrete, etc. The maximum K value is limited to 300 MPa per meter for design purpose. In some cases of DLC, it is exceeding 300 also, but it shall be limited to 300. Now, IRC SB 62 has given short ready-made tables. Instead of everybody don't like design also. That's why they have given shortcuts for how to fix the thickness of the CC roads. They have taken CBR of 4% and for up to commercial vehicle traffic of 50 CVPD. Yesterday also Amarendra has told something. Below the payment, what are to be proposed? WBM or WMM 75 mm thick or 100 mm thick GSP. This GSP minimum CBR is 30. That we have to satisfy this requirement. In some areas, we don't get good quality aggregates. Particularly in the North India, it is very difficult to get aggregates, and aggregates are very costly there. But if some marginal aggregates, like some aggregates having aggregate impact value more than 50% or so, in such cases we can treat it with cement or lime fly ash. Suppose instead of WMM 75 mm base course and 100 mm GSP, we can alternately provide 150 mm thick cementitious granular laying using marginal aggregates with a minimum UCS of 3 MPa. This is not CTSP. Please understand, CTSP is done generally with regular aggregates. The aggregates available with our in our state. This is 3 MPa. In CTSP, it is required 7 MPa. That's why we cannot call it CTSP. It is a cementitious granular laying using marginal aggregates. It is using 3 MPa at 7 days. If we use it with lime and fly ash, in 28 days, we have to get the same value. That is given here. But what is the thickness for 50 mm, up to 50 CVPD? This is 160 mm. We are required to provide a concrete, M30 concrete layer for 160 mm only. For giant spacing of 2.5 meters or 3.25 meters or 4 meters. IRC 58 stipulates a minimum maximum spacing of 4.5 meters, whereas here the giant spacings are less. For all the giant spacings, the thickness required is 160 mm. And if the K value is increased, because if the subject CVR is more than 4, and if it is up to 8 or 10, in such cases also we have to provide 150 mm as the minimum recommended thickness. That's why we can provide M30 concrete, and the thickness is also greatly reduced. For many internal roads, we cannot get more than 50 CVPD traffic. In such cases, we can adopt this 160 or 150 depending on the CVR. Up to 150, from 50 to 150, the thickness, they have taken CVR 4%. And the thicknesses are for 4 meters giant spacing, 190 mm. And zone 3 relates to us. That's why it is highlighted. For other zones also, thicknesses are there. If we adopt 2.5 meters, the thickness becomes 160. If we provide short slabs, shorter spacing, the advantage is we can reduce the thickness. And what is the subbase? GSB 100 mm and a WVM or WMM 75 mm. Similarly, this is not applicable for our area because we don't have problems with aggregates. Up to 250 CVPD, the thickness is same, but they have increased the WBM or WMM by 75 mm. We have to provide about 75 mm, one layer of the 150 mm WMM or two layers of WBM, and GSB 100 mm. The thicknesses are the same for the joints. We can use for all the low volume roads. We need not go for design. we can straight away adopt all these things, these tables.
Yeah.
Now, what are the cements we can use? This all the cements, 43, 53, TPC, PSC, all the cements as per we can use as per IS 269.
Will be conducted at
Portland slag cement, composite cement also we can use. Fly ash is used up to, can be used up to 25%, and GGBS can be used up to 50%. In case of sulfate resistant Portland cement, also we can use if soils around contain soluble salts like sulfates in excess of 0.5% or in excess of 0.2% in subgrade or in excess of 0.3% in groundwater. In such conditions solely, we can go for sulfate resistant cement. The cement content, minimum and maximum cement contents as per IRC 15, OPC, PPC, PSC, and the minimum cement content is 330 kgs per cubic meters. For fly ash and GGBS fly ash mixed cement, the minimum OPC content is 310 kgs per cubic meters. In case of GGBS blended cement, minimum OPC content is 250 kgs per cubic meters. The maximum limit of OPC content in any grade of concrete we shall not exceed by 450 kgs per cubic meter. These are the minimum and maximum cement contents. Fibers also we can use. We can use fibers to reduce shrinkage cracking and post cracking. As per IRC SP 46, we can do the mixed design. This code stipulates the standards of fibers. We have to do the mixed design as per IRC 44. And for DLC, IRC SP 49. These are the codes, these are the specifications for fibers. Now coming to sand. Sand, the IRC gave 3 gradations for use. Grading zone 1, zone 2, zone 3. We can find out approximately which zone it belongs. We can conduct by conducting a test on 600 microns also. If it takes some lot of time to do all the testing, then when field officers and the executive officers and sites, they can do CU analysis on 600 micron only, and they can approximately assess which zone the sand belongs to. But for finalizing the actual zone, we have to conduct the full CU analysis. Or if we go for this crushed sand, the limit becomes 0 to 20. If it is for river sand, the limit on 150 micron CU passing is 0 to 10. And if it is crushed sand, it becomes 20. Also, they have given 75 microns CU, not here, but they have given the maximum limit of coal 1%, maximum limit of coal and lignite 1%. Those are the limits of deleterious contents. And maximum limit of fraction passing 75 micron ISCU. If it is river sand, it shall be less than 3%. If it is crushed stone sand, it is 12%. And mix of natural sand and crushed sand, the limit is 8%. These are the percentages to be adopted after on 75 micron CU also. They can give this also in the table, but they prefer to give it as a footnote. This is zone 1 sand, this is zone 2 sand, this is zone 3 sand. As per IS 383, we have to follow. IS 383 also updated in revised in 2016. Fineness modules shall be between 2.0 to 3.5. Now, what is the physical requirements for coarse aggregates? Coarse aggregate shall satisfy requirements of IS 383. The main is this aggregate impact value shall be less than 30%. Up to 30% it can be allowed. Water absorption is up to 2%. This soundness is also required. The other important is combined flakiness index and elongation index. It shall not exceed 35%. This is the requirement for coarse aggregates as per IRC 15, which means that for high volume roads. This is a combined gradation of dry lean concrete. The mixed design as per IRC SP 49. EQC mixed design is as per IRC 44, whereas the mixed design for dry lean concrete is as per IRC SP 49. The combined gradations means coarse aggregate and fine aggregate. In this, what we have to note that the 7-day average compressive strength of each consecutive group of 5 cubes shall not be less than 7 MPa. This is as per IRC 15. But in the MOT, it is given as 10. But 10 is very not economical. That's why, because it is MOT has come in 2013. This code has come in 2017. That's why it is better to follow this one. 7-day strength 7 MPa means it is likely to get the M10. But it shall not be less than 10 MPa for PQC bonded DLC. Suppose if we are not providing this separation membrane, then the strength of DLC, the 7-day strength shall be 10 MPa. This is, which is 7-day strength 10 MPa means it is about M15 grade. In case of PQC bonded DLC, its surface shall be roughened with wire brushes 3 to 6 hours before after laying. For better bonding, we have to roughen the surface, DLC surface, 3 to 6 hours after laying. Now, actually, in the MOT, they have given only one gradation for PQC. But IRC 15 has given 3 gradations because in the ready mix plant and concrete mixing plant also, it may not be easy to adopt this gradation. Although ready mix plant owners prefer this gradation because if they use this higher aggregates, thus the belts etc. are likely to get damaged very fast. That's why they have given 3 gradations. This is 31.5 nominal size, this is 26.5 nominal size, and this is 19 mm nominal size. This is somewhat similar to the grade of aggregates we are using for the concrete for buildings, etc. It is we can. That's why all ready mix plant owners prefer this gradation. For crushed sand also, they have given this table. This is for crushed sand. This is for natural sand. The gradations, if we are using this crushed sand, we have to check it. Now, the aggregates, combined gradation of aggregates for low volume CC road, that is M30 concrete. The combined gradation is this one. You observe the gradation is also similar to the grading, slightly different to the grading 3 shown earlier. Here the water absorption is 5%, up to 5% we can allow. If it exceeds 3%, we have to conduct soundness test. Here what is given instead of flakiness and elongation, they have given only flakiness index value for up to 35%. Whereas in IRC 15, combined elongation index, combined flakiness and elongation, we have to check it. That is the difference. In IRC 58, the water absorption is less than 2%. Here it is up to, we can allow up to 5%. Now coming to water, water is also plays a very important role. The water solute ratio is also very important, and the quality of water mixing in the concrete and curing also very important. Potable water automatically naturally satisfies all the requirements, but we have to send the water to the laboratory to test about the impurities present in the water. These are the limits given in the IS 456 for each sulfate, chlorides, etc. And pH value of water shall not be less than 6%. 6. It is not percent. pH value shall not be less than 6. Now, for the concreting, the weather also plays very important role. It is always better to do concreting during evenings and early mornings and nights also. Also, one important aspect is that the concrete temperature at the time of placement shall not exceed 30 degrees. This is very important. It is also very difficult to achieve at many sites. They have to use chilled water. We have to cool aggregate also in some cases, because Santosh Kumar has told the aggregate's temperature is also plays an important role. Cold water is important, and also atmospheric also we have to ambient temperature above shall be less than 35 degrees, and relative humidity shall not be less than 25%, and wind velocity 15 kilometers per second. If any of these conditions, the evaporation losses are evaporation is very high. That's why if it is inevitable to do concreting in such climates, we have to take appropriate protective measures. Otherwise, it is better to do concreting in the mornings and the evenings and during night. That is also important, because maintaining concrete temperature below 30 degrees is very, very important. In cold climates, if the temperature is less than 5 degrees centigrade also, we cannot allow concrete. Now coming to the embankment and subgrade, now we are going into the construction aspect. The liquid limit, velocity index, free swell index are three important items for the MDD. These are the items that decides the suitability of the soils we are going to add. For embankment, subgrade and shoulders, these values are 50%, 25%, 50%. They are same for both embankment, subgrade and shoulders. But MDD varies for embankment and subgrade and shoulders. As per IRC 58, the minimum subgrades CBR, it is stipulated as 8%. The camber and slope elevation of subgrade shall be same as that of DLC and PKC. For all the concrete rates, we have to provide camber also. Some people think that it is not required to provide camber for CC roads, but it is very much required. Suppose we come across some expensive soil, embankment soils. What IRC 15 recommends? Where the embankment consists of clay having liquid limit more than 50%, such as black cotton soil. Actually, this is not the liquid limit, this is free swell index. If the free swell index is more than 50%, even liquid limit also shall not be more than 50%. These subgrade soils should be stabilized with lime and cement or any other approved stabilizer to achieve a minimum CBR of 15% for the subgrade. Suppose we are having subgrade soil, some subgrade soil of about CBR 8%, and but the subgrade is resting on the embankment having expansive nature. In such case, it recommends to improve the CBR up to 15% for the subgrade. If you increase the CBR of subgrade 15%, you can allow expansive soils below subgrade also. Subgrade. Alternatively, the top 500 mm thick black cotton soil should be replaced with suitable soil of minimum CBR of 8%. If it is not economical and feasible to stabilize the CBR, subgrade CBR, to increase the CBR up to 15%, the alternative is to replace the top 500 mm layer of embankment with a selected soil giving a CBR of 8%. This is for subgrade on embankment soil, expansive embankment. In waterlogged areas and where the subgrade soil is impregnated with deleterious salts such as sodium sulfate, etc., in excess of permissible limits, a 150 mm capillary cutoff should be provided before constructing the subbase. Capillary cutoff means some sand layer or sand and stone dust mixture also we can adapt as a capillary layer. This is 150 mm thick. In waterlogged areas, these are the recommendations as per IRC 15. Now this is the subgrade, compaction of the subgrade. This is a field density test using sand replacement method. The relative compaction shall be not less than 97%. Now the both has given gradation 6 gradations for GSB. From the visible observations, we can tell these two gradations are open graded. 1, 2, 5, 6 are related to the closed graded. Because they are going to be, this 1, 2, 5 and 6 are having less voids. They are dense graded GSBs. This is open graded GSB or open graded GSB or coarse graded GSB. For drainage layer, grading 3 and 4 are suitable. For filtration or separation layer, grading 1, 2, 5, 6 can be adopted. For GSB, what are the requirements? AAV shall not be more than 40%. Liquid limit shall not be more than 25%. Mass city index shall not be more than 6%. CBR minimum 30%. But in many cases, what we are using coarse grades for GSB, we are likely to get CBR of 80 to 100%. If the water absorption is greater than 2%, wet aggregate impact test shall be conducted. And what is the difference between aggregate impact test and wet aggregate? We have to soak the aggregates for 24 hours in water. After that, we have to conduct the test. This IRC 37 also recommends grading 3 and 4 for drainage layers and grading 1, 2, 5, 6 in as a separation layer. Now this is GSB as per MORTH grading 5. You observe the closeness of the denseness of the aggregate layer. It is very densely packed. It is used to, it gives a lot of strength, about 100% CBR also. But it prevents the ingress of soil from the bottom layers. Because its function is to ingress the soil from the bottom subgrade, etc., It is called as filter layer or saturation layer, separation layer. This is a DSB getting compacted. After the compaction, we have to, of a particular layer, we have to conduct field density test, and the relative compaction shall be not less than 98% for GSP. This is sand replacement method for conducting field density test. You observe the difference between grading 4 and grading 5. This is grading GSP with grading 4. You observe more whites here. That's why permeability is more with this layer than compared to zone 5, grading 5. In this also, permeability is also required, as per required also. Generally, they require 300 meters per day permeability. It satisfies that requirement in many cases. But this gives a permeability up to 500 also. But it is always preferable to go for this one for drainage layer. But if you are not providing for full width, whatever GSB you are providing, it won't matter. If it is provided for full width only, then it will be function as drainage layer. That's why for roads where very many R&D roads, they are not providing GSP for full width. In such cases, they need not go for grading 4, 3 and 4. They can go for grading 5 or 6. This is the gradation given in the MOD Ministry of Rural Development specifications. That is, when we are following SP62, we have to adopt this gradation. This gradation is the mostly in Panchayat Raj department, they are following GSP for this gradation. Earlier, in R&B also, they used to follow the same gradation for GSP for all the roads. Because in 4th revision, this same table is given. That's why for all the old R&B roads, they are using this gradation. Whereas in Panchayat Raj works, they are using this gradation now. This is the grading that this gradation. It consists of 12 mm, 6 mm and dust. Its performance on 4 subgrades is very good. This is the same type of material used for the full width in one R&D work. Now coming to the concrete, this is the concrete batching plant. This is erected for constructing a 6-lane CC road. Then this work is still going on. For cooling the water, they are having this chilling plant with 25,000 liter capacity insulated storage tanks. The chilled water is to be kept in the insulated tanks so that the temperature is not likely to increase. Even after mixing that chilled water also, they are finding it difficult to control the concrete temperature below 30 degrees centigrade. That's why what is you please understand the importance of controlling the concrete temperature. Builders may be there in the power also, and it is supplemented by the compaction with the roller. Here also paving the DLC. Because it is a slip form type paver, we are not having any shuttering arrangement. This is compaction of DLC. In a wet condition, it appears slightly blackish. Afterwards, it appears as become whitened. This is also rolling dry railing concrete. Generally, we require 7 days curing for DLC because after 7 days they start laying PQC. They have covered curing by covering with wet gunny bags. These are the gunny bags, and they have to water it. We can apply curing compound also, but they prefer this wet gunny bags as a better for this dry line concrete. Here, for dry line concrete also, we have to conduct field density test. Here also, we have to get 98% minimum density. This is slip form favor for M40 PQC. We can have any grade of concrete. Concrete grade is not specified for the favor. In this work, the PQC requirement is M40. It is having attachments for texturing and also having working bridge attachments, etc. They are having this. Here they are dumping this concrete from the batching plant using GSP, and they are dumping it before the paper. They are checking the temperature of concrete also. It shall not be more than 30 degrees. They fix grid-wise and are having this sensors based on which the width, etc. are obtained. Here you see this 150 micron thick plastic sheet as separation membrane. Earlier it is stipulated to be 125 mm. Now they have changed it to 150 micron. This membrane shall be transparent or white in color. We have to provide either white sheet or reflective sheet not to increase the temperature of the concrete. If it is a dark colored one, it absorbs some rays and increase the height of temperature of the concrete. That's why they are recommended this white or transparent. What is the function of this one? This is DLC, this is the PQC. It functions as a roller in between the two concretes, in between DLC and there is no friction between the DLC and PQC. They are casting these beams and cubes for testing. Cubes are for testing compressive strength and beams are for flexural strength. Now this is the testing of cubes and testing of beams. The beams are here. In IRC 15, it is stipulated to do the flexural strength test by third point loading. Surendra Singh was telling that 4-point loading is better, but IRC 15 has given this third point loading. This is 3-point loading. These are the beams. This is the PQC favored by this slip form favor. The finishing is done. Initial finishing is done with sober smoother. Now dowel bars already lot of number of times they have told. All the important items I will cover. Dowel bars are required at contraction joints also if traffic intensity is more than 450 commercial vehicles. Dowel bars are required at contraction joints also if traffic intensity is more than 450 commercial vehicles per day. For low volume roads, we need not provide dowel bars at contraction joints. We can provide the dowels at construction joints, but we need not provide dowel bars at contraction joints. Now, the necessity of providing the dowel bars can be understood. This is the dowel bar, this side fixed end, this side free end. The free end shall be in the opposite direction of the vehicle movement. We have to provide free end on the opposite side of the vehicle movement. Generally, we do concreting in the traffic vehicle direction only. That's why we have to fix the dowel bar fixed end this side, and free end this side. This is free end. Also, this alignment tolerances are also given a RC50. The alignment misalignment also leads to a lot of problems. This element of dowel bars. The allowances are given here. These are the what are the diameters of diameter, etc. for the dowel bars. Dowel bar shall be provided at contraction joints also in the traffic. Dowel bars need not be provided at contraction joints for slabs of less than 200 mm thick. If the thickness of slabs is less than 200 mm, we need not provide dowel bars at contraction joints. This is the dowel bar inserter. After insertion, it appears like this. Now these dowel bars shall be having these plastic sheets to cover these dowel bars. And here they are covering it with mastic tape so that slurry or this concrete is prevented to enter into this. That's why they have to provide this slaves. This is the fixed end, this is the free end. These are the dowel bars. This is the arrangement when we are doing concrete with fixed formula. The dowel bars, etc. are fixed. This is the spacing arrangement, spacing and diameters of tie bars. Now IRC 58 recommends FE 500 tie bars. And we have to note in curved or gradient portion, spacing shall be reduced by 30%. The spacing shall be reduced by 30%. We have to provide more tie bars at the curves and gradients to prevent separation. These are the dowel bar tie rods. This is the fixing of tie bars. This is the tie bars. This is the longitudinal joint. After super smoother, it is the working bridge on which they are having floats, etc. They are trimming the edges. They can using the floats also in a minor irregularities they can set right. Now texturing by tining. This is longitudinal texturing or transverse texturing. In India, mostly we are doing transverse texturing. Longitudinal texturing can also done. This is the texturing machine. It can move on this tracks. About 3 to 4 mm depth, it will cut. This is applying curing compound after texturing. Texturing is to be done prior to the application of curing compound. This is the textured surface after. This is after application of this curing compound. Now they are measuring undulations with 3 meters straight edge, and they are measuring the depth of texture also. Now they have done initial curing with curing compound. Curing compound can be serve the purpose for maximum 2 or 3 days. Now they have done this curing by sprinkler arrangement. Water is sprinkled regularly to keep the surface wet. The curing purpose of curing is to prevent the evaporation losses. Actually, what is the mixer? Water mixed in the concrete is enough for the total hydration of the concrete. But it is likely to get evaporated if we don't do the curing. By making such arrangements, it can be done effectively. One important item is this curing is to be done for 14 days. If we do concrete with OPC, and 16 days if it is done with blended cements. This is important item. Please observe it. If it is OPC concrete, 14 days curing is required. If it is blended concrete, blended cement concrete, we have to do for 16 days. This is initial joint cutting. Initial joint cutting, 4 to 8 hours if the temperature is more than 30 degrees centigrade. And it shall be between 8 to 12 hours if the temperature is less than 30 degrees centigrade. Joints are how to cut the joints. Initial cut are slot 2.5 mm to 5 mm with a depth of 1/3 to 1/4. After 4 hours, after 14 days, we have to widen the joints. Mostly we are providing construction joints and contraction joints. Expand joints are not being provided now except in the concrete slab its bridges. In joint spacing at curve portion may be reduced by 20 to 30% because the slab configuration is considered as 3.5 meters into 4.5 meters during design. That's why in curve portions the span is likely to increase by this designed spans. That's why in such case we have to reduce the joint spacing to limit the length and width of the panels to 3.5 meters and 4.5 meters. These are the joints in the concrete, joints, everything. This is a 6-lane project on which I am showing the photos. Each lane is 3.5 meters. The shoulder here is 2.5 meters. Nowadays, they are recommending shoulders of 2.5 meters. For national highways and expressways, etc., we have to provide 0.5 meters extra for curb shyness, so that vehicles are cannot ram this divider. That we have to provide 0.5 meters extras. We are having 4 types of joints. This expand joints only we can provide it. We have to provide it bridge locations, etc. This is the contraction joint. This is the dowel bar. This plastic sheet about 60% length. We have covered this plastic sheet. Initially, we cut it to 2.5 to 5 mm groove. After 14 days, we will widen the groove to 8 to 10 mm and up to 20 mm to 25 mm deep. But initial cutting is up to 1/3 to 1/4. This is dowel bar at contraction joint. Why we are providing contraction joints? To relieve stresses due to warping. Warping is due to changes in moisture. Contraction of slab due to expansion curling effect. And the slab is contracting. If we don't provide contraction joint, it is likely to crack. The spacing of contraction joint should be limited to 4.5 meters for high volume roads and low volume roads. If it varies for low volume roads, it varies from 2.5 to 4 meters. If the width of the pavement is more than 4.5 meters, we have to provide longitudinal joint. Now you see this joint is cut here. Because the joint is cut here, the cross-section area is reduced here. If it is 300 mm here, it is about 250 mm or 240 mm here. That's why area of cross-section is reduced due to this tensile stresses, etc. The crack is observed here. If we do not cut this joint, if the joint is not cut, some irregular crack appears on the top of the CC road. It is not at all desirable to have an irregular crack on the surface. That's why we are providing this contrast joints by simply reducing the cross section at some locations. This is the longitudinal joint. This is tie rod. Dowel bars are mild steel, but tie rods are tall steel. They recommend the FE 500 tall steel bars for this contraction joint. The slot is similar to the contraction joint. Longitudinal joints, if the width is more than 4.5, we will provide. In two-lane roads, generally they provide 3.5 meters because the width is 7 meters. Mainly purpose is to hold both the lanes together. To prevent separation also we are providing, and to prevent, if we don't provide this longitudinal joint, longitudinal cracks are likely to occur. This expansion joint, this is expansion feller board, compressible feller board, and this is the dowel bars. Generally, because it is not possible to maintain expansion joints in CC roads, we are having this, providing contraction joints at dowel bars at contraction joints. Some feasible possibility of expansion at contraction joints. It was decided to dispense with expansion joints on CC roads. They are therefore not in use. The current practice is to provide these joints only when concrete slab abuts with bridge or slab culvert. At that portion only we have to provide that one. This is the expansion joint. This is about 20 to 25 mm width. This is the same dowel rod we are providing at the contraction joint. But one addition is that we are providing one cap, and in this this width of this joint space shall be provided here. It is to be filled with cotton or sponge, this cap, to facilitate the movement of this rod at expansion joint. That is the difference between contraction joint and expansion joint. Here the slabs are fully separated, and this filler board is provided, and also some gap here to be filled by cotton or sponge. This is the construction joint provided in with the slip for paver. You see observe the dowel bars with the cover. This is the free end. You can see the plastic sheeting also. Plastic sheeting covering the dowels here. Where plastic sheeting is not there, it has gone inside. We have to maintain this like this. If we don't cut the joints earlier, this type of irregular cracking is likely on top. And if we cut the joints early, it will be like this. That's why they have given a window for cutting the joints. It shall be done before 12 hours. When the slab, this CC road abuts a bridge, we have to provide this anchor beam and terminal slab. This is the terminal slab. This is the anchor beam with some nominal reinforcement. This is the expansion joint. This is the approach slab of the bridge. Transit slab between rigid and flexible pavement. At many places, they are not joining the CC road and BT road. Actually, we have to follow this about 4 meters length. We have to give steps in the PQC so that the BT road joins it smoothly. Here also some beam is to be provided. The ceiling compound, when the slabs contract, it will be like this, and when it contracts, it will be like this. When slabs expands, it will be like this. There are 3 types of ceiling compounds are there. This is a separation membrane, debonding strip. If we are using hot rubberized, we have to heat resistant debonding strip we have to use in the joints. This is contraction joints, this is expansion joint. 3 types of sealants are recommended. This is cold polysulfate sealant. This is hot. This is bagger rod. I will show the photos. Now the PQC surface after 14 to 16 days. After 14 days or 16 days, we have to widen the grooves. 2.5 to 5 mm grooves. We have to widen it. In this project drawing, they have given for this. This is for longitudinal joint. The shape also they have given like this. This is the ceiling compound. This is the backup rod. This is 10 mm. This is 8 mm. We have to widen it to 8 mm. Here it is 10 mm width. Here it is 12 plus 10 plus about 25 mm total. The depth of total widening. This is the cutting. They are widening the slot. And after that, they are using the compressed air to clean it. Now they are pushing backer rod. This is the backer rod into the slot, widened slot. They are pushing the backer rod. Why backer rod was provided? To prevent the ceiling compound to go into the slot. To prevent the ceiling compound from going into the bottom, this we have to provide this backer. No, before applying seal coat, they have masking tape is fixed on both sides, so that if some ceiling compound overflows also, it won't touch the CC, tether to the concrete surface. To prevent it, they have fixed this masking tape. Now they are mixing the polysulfate sealant, hardener, they are mixing by using this, and they are filling to the applicator. This material they are applying into this. Now they are applying this sealing compound. First, they are applying primer application. This is primer application before the sealant application. This is the sealant application. This is also sealant application. This is also they are having some tool so that after applying this one, we will get the finishing like this at the joint. They are pushing this. They are using the sink thing to give a shape of this shape to the sealing joint. They are also removing the surplus sealant. This is the surplus they are removing. After completion, it will be like this. This is the longitudinal joint. These are the constriction joints. These are the contraction joints, not constriction joints. Now, rigid pavement using this semi-mechanical. Many of our roads are done with mechanical and. Amarendra garu, how much time is left? Here they have used this 125 micron sieve. They are placing the concrete on the separation membrane. This compaction of concrete is also very important. For any concrete, compaction is important. Compaction is necessary to remove entrapped air present in the concrete after it is mixed, transported, and placed. Compaction also eliminates stone pockets and remove all types of voids. Consideration is the process of making the freshly placed PCC or PQC into a more uniform and compact mass by eliminating undesirable air voids and causing it to move around potential obstructions. This is the purpose of the concreting, compaction. Here they are using this screed compactor. This is plate compactor. They are testing the slump and temp. This is slump test. Here they are checking the temperature of the concrete. Here the slump is 40 to 60 mm. Here they are checking the depth of the concrete. They are doing this troweling by floating with the trowel, finishing the concrete slab. Also, the straight edging is also there to check the undulations, etc., and to remove any surplus and depression, to make up the depressions or etc. to accept the concrete. Afterwards, compaction with plate vibrator and finishing by belting. This is belting. They are doing finishing. Here for manual construction, etc., we have to do the texturing by brushing. The brushed surface texture shall be applied evenly across the slab in one direction by the use of wide brush, not less than 450 mm wide, but wider brushes may normally of 3 meters length are preferred. 5 individual measurements of the texture depth shall be taken at least 2 meters apart anywhere along a diagonal line across a lane with between 0.50 meters. This is how to. This texture depth shall be determined by sand patch test. About 1 mm is the depth of this texture, but by tining, the depth is 3 to 4 mm. That's why it is recommended to provide 10 mm thick extra thickness for the slab. This is texturing by wire brush. It will be like this. For the dowel bars, as for low volume roads, MS 25 mm dia, 450 mm length and spaced at 250 mm. Center to are to be provided at expand joints. Or we have to provide nowadays expand joints are removed. We have to provide dowel bars at construction joints. We need not provide dowel bars at contraction joints if the traffic is less than 450 commercial vehicles. Construction joints shall be provided at the end of the day's work or when work is sustained for more than 90 minutes. We have to provide this construction joints. This is the expansion joint to be provided where the CC road is abutting this bridges are this. This is as per ARC-SP 62. Construction joints also, these are the construction joints. We have to take care of so that the construction joint shall coincide with the contraction joint. Here they have used these bulkheads to get the neat finish. Here also you see this. They have used these bulkheads to get the full depth of the butt joint. This is the dowel bar. They have used this mastic pad and this plastic sheet they used to, in those days, it is taken some 20 or 15 years back. In those days, they are using this plastic sheet and also they are using a small cap here also. This is the dowel bar. They are doing concrete from that side. That's why they are providing free hand this side. This is paving near culverts and bridges. This is the road. They have to put this dowel bar inside into the slab. CC road joint with new bridge as per ARC-SP 62. We have to follow this one. This is for the new bridge. We have to provide this dowel bar, etc. at the end so that it can be joined with this pavement slab. If it is an existing structure, we have to provide like this. We have to drill dowel bar into it and join it. The expand joint is like this at bridges. This is the expand joint. Here they are providing some additional GSB. Here the expansionary joint is provided between the approach slab and the bridge. Here also they have given one joint. Now curing is the process of maintaining a satisfactory moisture content and favorable temperature in the concrete during hydration of the cementitious material, so that the desired properties of the concrete are developed. Its objective is specifically to keep the concrete saturated until the water-filled spaces in fresh cement paste are filled to the desired extent by products of hydration. This is the saturated concrete. We should protect this moisture from evaporation. That is called curing. We need not add additional water for concrete hydration. We have to protect the water from getting evaporated. That is the meaning of this concrete curing. There are different types of curing, bonding with water, So many items everybody knows. We have to do for 14 days and 16 days for blended cement concrete. If we don't proper curing, these are the problems. The mistake most of our people are doing is that they are not doing curing the first 24 hours. That is a major mistake for all the concrete works. What given in more, you please read. After finishing, the pavement surface shall be entirely covered with wet Hessian cloth, burlap or jute mats. The coverings used shall be of such size that when laid will extend by 500 mm beyond slabs. They shall be placed as soon as the concrete has set sufficiently hard to prevent marring of the surface. They shall be placed as soon as the concrete has set sufficiently to prevent marring of the surface. They shall be maintained fully wetted for 24 hours. The concrete slab shall not be exposed for more than 10 hours or so. You see the alignment of the dowels is also not correct. So alignment problem is also there. What happens to the slab? Already fully dry, getting completely water is evaporated, it becomes totally dry. The concrete is laid some 2 hours back or so, 3 hours or so. Up to 1 hour or so, the moisture will be there. If it is daytime during sun, it is likely to evaporate within 1 hour. We should not allow any concrete to be left like this. We have to use some method, suitable method, which will not mar the surface, spoil the surface of the concrete, to cover it with some wet items, lightweight items or something. At least if no light material is not available, we can go for this curing compound. Curing compound, after 24 hours, we will go for this blind bonding. Most of the concrete road works are like this only. Even concrete slabs for buildings, structures also, they are left like this, even for bridge slabs, etc. This is the major problem observed during execution. It needs to be controlled. That's why we are not getting the required strength when cores are taken from the concrete. You see this one, this type of curing, they are using this jute mats. This gunny rolls cloth, gunny rolls are available. Each is having about 50 meters length or so. It is very lightweight. The concrete, they are doing curing with this one. Edges also, edge slabs also, we have to protect by pushing some soil or something. Edges also shall not be exposed to the. This coir is also very useful because weight is very less. We can use coir after 3 hours of concreting. Generally, a final setting time is around 6 hours per concrete. We can use this type of curing method after 3 to 4 hours, depending upon the hardness of the concrete. They have also poured some adjoining soil, which is fine sand. They have covered it with this one. And again, they are watering it only. No water is likely to get evaporated from the concrete here. It is a perfect type of curing. Here also you see the gunny rolls. They are very lightweight. This is curing by ponding. But this is done after more than 24 hours. Before that, curing is important. That is most important. This can be done up to 14 days or 16 days. But if we don't do the curing in the first 24 hours, that may result in poor concrete strength. This is application of curing compound, X-based curing compound. it reflects the sun rays so that heat won't go into the concrete and water is not likely to be evaporated. It is good for 1 or 2 days. If it is not disturbed, it works well for 1 or 2 days. This is a wet gunny bags curing cover. Here they are cutting the joints. After the joints are cut, these are the low volume roads. Here the original joint cut.
Excuse me,
Now
sir.
it is widened. Now they are using the sealing compound. Now the sealing compound is coming onto the concrete surface.
Excuse me, sir.
Time is over.
Sir, another 10 minutes you can continue presentation, sir. Then last 10 minutes we will take up the question and answer.
Okay, thank you.
So by 1 o'clock we will wind up the.
Okay, right. They are applying the sealing compound. Now they are removing the surplus sealing compound with this. This is also joints formed by placing metal strips, metal angles. They fix a T metal T's, and they are removed before the concrete sets. These are the joints. This is also, we can also provide reformed slip joints also. After this, I have to cast cubes and beams. These are the outwards they are taking cores. Generally, cores are required whether there is any doubt about the strength of the concrete. Nowadays, for the government department, most of the vigilance and enforcement people are taking course after construction. If we do the curing, etc., and control the water-cement ratio, we need not worry about the strength of the concrete. Those two items we have to control very well. After cores are taken, they are testing it in the CTM. Now, how to accept, as for IRC 15, what is the acceptance criteria of strength, flexural strength? If the cores are taken, the mean strength determined from any group of 4 consecutive samples, each sample containing 3 beam specimens. First, we have to take 3 samples. We have to test the 3 beams. The average values becomes the sample value at 28 days. It should exceed the specified characteristic flexural strength. If it is 4.5, we have to exceed it by 0.3 MPa. If we get 4.8 MPa, the equivalent flexural strength for beams, we can consider it the concrete is having 4.5 MPa flexural strength. That is the acceptance criteria. The group of 4 samples, consecutive samples, each sample containing 3 beam specimens, should exceed the specified characteristic flexural strength by at least 0.3 MPa. If we get 4.8 MPa or more, we can accept the concrete is having a flexural strength of 4.5 MPa. The strength of any specimen is not less than the specified characteristic flexural strength 4.5 MPa minus 0.1 MPa. Here we have tested 12 samples. 12 specimens we have tested. 4 samples means 12 specimens. In any one of the 12 samples should not give a flexural strength of 4.4. Up to 4, one sample is permitted to get a flexural strength up to 4.4. but all the 11 samples must get more than 4.5, and the average shall be 4.8. This is the acceptance criteria for the flexural strength. Now, what is the acceptance criteria for flexural compressive strength? The main strength determined. Generally, we test the cubes. Generally, cores are tested by when some people like Reliance people are comes, they take cores. We can also take guarantee for the guaranteeing the strength, checking the guarantee strength of the also. But generally, we generally test the cubes. 4 consecutive samples, each sample containing 3 cube specimens, should exceed the specified characteristic compressive strength by at least 3 MPa. If it is a M40 concrete, the cubes in the cube test we shall get at least 43 MPa. Then we can treat the concrete strength in the slab as 40. That is the requirement. The strength of any specimen is not less than the specified characteristic strength compressive strength minus 0.1 MPa. Among the 12 samples, 12 specimens, not samples, mostly it is considered samples and specimens. One sample means three specimens. At least one, it is allowed if for only one specimen to get a strength of 40 minus 1, 39 MPa, we can accept. This is the criteria requirement for IRC 15. But more the requirements is that if we get 3 MPa minus 3 also, it can be allowed. For low volume roads, we can allow it up to, if it is minus 3 MPa also, we can accept. That is the reference. This is how to about the course. After taking the course and testing, we have to apply the formula that we have to find out the equivalent cube strength. If we divide this by the core strength value divided by 0.8, we will get the equivalent cube strength. Then again, we have to divide multiply this with 0.85. Suppose M40 concrete is there, we require M40 into 0.85, which means that 34 MPa, we have to get 34 MPa, equivalent cube strength of 34 MPa. Equivalent cube strength is equal to core strength into 1.25 divided by 0.8 means 1.25 to multiply. After that, we have to get a value of 34 MPa for accepting M40 concrete. If the depth to diameter ratio is not 2, we have to apply this correction. These are the other quality control requirements as per which tests are done like that. As per IRC 15, these requirements are given. These are the quality requirements for as per all the specifications. That is when we are adopting IRC SP 62, we have to follow these guidelines. Uh, this is my presentation. End of the presentation. Uh, Hello, Amrendra.
Hello, sir.
Hello.
Sir.
That is the end of my presentation.
Thank you, sir.
Thank you, sir. Thank you very much, sir. Sir, I request you to go through the chat box, sir. There are some questions.
అడ్రస్ చేయాలి సార్. ఓకే సార్. ఇప్పుడు మీరు జాయిన్ అయితే సార్.
సార్ గుడ్ ఆఫ్టర్నూన్ సార్. బాగున్నారని సార్. బాగున్నారా సార్? యా యా.
Good afternoon.
Sir, good afternoon, sir.
Good afternoon.
Sir, Chancellor sir is joining in 2-3 minutes, sir. Just let's.
Okay.
Dear participants, please mute your microphone as well as camera.
Sir, Director sir, good afternoon, sir. Sir, please unmute your mic, sir, Director sir. Unmute, sir, please unmute your microphone.
Director sir, please unmute your mic, sir.
Good afternoon, all of you. The valedictory session is about to start. So I request the participant to wait for a minute. Our Honorable Chancellor of RGUKT is going to join us in a minute. So please wait for a while. Thank you.
Sir, good afternoon, sir. This is Amarendra, sir. Sir, please unmute your mic, sir.
Sir, good afternoon, sir. Welcome, sir.
Okay.
Yeah.
Yeah, go ahead.
Yeah. I request HOD Civil Engineering Department to start the valedictory function.
Yes, sir. Thank you very much, Dr. Amarendra Chandra. Let me introduce myself. My name is J. Saran Kumar, Head of the Department of RK Valley.
ఇది నీది సార్ ఇక్కడ మ్యూట్ లో ఉంది సార్ వాళ్ళు పెట్టారా
Go ahead.
సార్ గుడ్ ఈవినింగ్ సార్
Good evening. Good evening.
లేదు సార్
Sir, am I audible now, sir?
Yes.
Yeah, you are audible.
Thank you. Thank you, sir. Sir, let me introduce myself. My name is J. Saran Kumar, Head of the Department of Civil Engineering, RK Valley Campus, RGUKT University of Knowledge Technologies. Respected Chief Economist FDP and Chief Guest of this function, Professor K.C. Reddy Garu, Chancellor of RGUKT University of Knowledge Technologies, Andhra Pradesh. Respected Guest of Honor, Shri D.V. Bhavana Rao Garu, Retired Chief Engineer, R&D, Government of Andhra Pradesh. Respected Patron and Guest of Honor, Professor P. Sujit Kumar Garu, Director of RK Valley Campus, RGUKT AP. Mr. Mohan Krishna Chaudhary, the Administrative Officer of RK Valley Campus, Dr. G. Ramesh, the Dean of Academics, Mr. B.V. Sudhakar Reddy, Finance Officer of RK Valley Campus, the coordinator and the co-coordinator of this FDP, the organizing members, the participants, student friends, ladies and gentlemen. A very good welcome to all. It gives me immense pleasure to be part of this FDP and make a grand success. And with this, I request Dr. Amarendra Kumar Chandra, Associate Professor and FDP Coordinator, to present a brief summary on this FDP on recent developments in cement concrete pavements, various cementitious materials, admixtures, testing protocols, mix design, and pavement design. Thank you.
Thank you, Saran. Respected dignitaries, Professor K.C. Reddy Garu, Honorable Chancellor RGUKT, Sri D.V. Bhavanarao Garu, Retired Chief Engineer R&D, Government of Andhra Pradesh, Professor Sudhir Prem Kumar, Director RGUKT-RK Valley, Administrative Officer, Finance Officer, faculty colleagues, and my dear participants, a good afternoon to you all. I am here to present a brief summary of the 5-day faculty development program. Recent years has seen numerous advances in cement concrete and bituminous concrete pavements in terms of materials, design of mixes, pavement design, and construction. And so we felt that a platform need to be created to explain these advances to the teaching community and practicing engineers by experts of national and international standing. With this objective, we the faculty members of Civil Engineering Department have sent two proposals, AICTE Teaching and Learning Atal Academy, one on bituminous pavement and other on cement concrete pavements, and requested to sponsor for conducting faculty development programs. The Atal Academy had sponsored for organizing an FDP on cement concrete pavement, and we are confident that we may get permission for organizing similar program on bituminous concrete pavements in near future as well. Total 302 participants across the country have shown interest to attend the program. However, as per the Atal academic guidelines, we have limited to 200 participants. We have noticed that the participants from 26 states / union territories were attended the program. Through 15 technical sessions in last 5 days, the experts covered various topics such as fundamentals of concrete pavements, mixed designs, advanced testing procedures, pavement design as per latest guidelines, analysis and construction of joints in concrete pavements, design of high strength concrete mixes, concrete overlays, design of rural road concrete pavements, pervious concrete pavements for sustainable development, innovative materials used in concrete mixes, and construction of concrete pavements. In addition, we have also organized 2 sessions on stress management through Sahaja Yoga, meditation, and Fit India movement. So through these lectures, I am very confident that participants must have gained good amount of knowledge in the area of cement concrete pavements, and also these technical sessions thrown some light on the research gaps in various areas of concrete pavements. I sincerely thank the administration of RGUKT for their continued support and encouragement to organize this program, and expecting same in the future. Thank you, sir.
Thank you very much, sir. Before going ahead, I would like to call a few participants to give feedback on this FDP on recent developments in concrete pavements. So I request Mr. Chaitanya to coordinate and complete the session within 5 to 10 minutes. Thank you.
Good afternoon to one and all. So participants, please come forward to give your feedback. Your suggestions will help us to improve and conduct future workshops and conferences without any bottlenecks. So before giving your feedback, please mention your name, designation, institute, and place.
Hello.
Yes, sir.
Yes, sir.
Hello, I am Dr. P.D. Kumbar from Maharashtra. My institute is Rajaram Bapu Institute of Technology, Rajaram Nagar, Sangli district. And I have joined this course, though I'm not pertaining to construction management. Particularly, I'm dealing with the structural engineering, but I was having some interest in joining this particular say program. I could conduct this particular say program. Sorry, am I audible? Hello.
Yes, sir. Yes, audible, sir.
Yes, yes. So for last 4 days, I could enjoy the sessions of all the experts who very nicely conducted the session. I could get very nice information pertaining to this particular say construction of highways, construction of the or manufacture. I'm sorry, the research works particularly carried out in the related to this particular say materials which are used for construction of highways, etc. And the entire program was very well organized. It was started it was used to start on exact timing which was scheduled. So I must thank all the organizers and all the team members for very nicely well organized program, because in our institute also we have conducted several such programs, but not like the one which has got a sanction from AICT or so. But I wish all the best for the future progress of your institute and the university. I am very much thankful to all the organizers and the team members, and even to the AICT for allowing me to be participant of this particular program. Thank you very much, and good day, sir. Thank you. Over to you, sir.
Thanks, sir. Thanks for your kind words, sir. Anyone?
Hello. Sir, good afternoon, sir. Hello.
Yes, sir. Yes, sir. Yes, sir. You are audible.
Dr. B. Damodar Reddy, working as a professor and head in Sri Venkateswara College of Engineering in the Chittoor. Sir, the program was very well organized. Regarding design and construction aspects, they have explained very nicely, and white topping technology for urban roads, as Ramachandra sir has told very nicely, sir. Very basics and fundamentals, everything they have explained very nicely. The experts selected for this event is very nice, and the design of concrete pavement, Amarendra sir has told very nicely, but time is very less, but sir has shown very good slides, and Bhavan Rao sir lost today's session is very nice and attractive. Some of the professors has shown the case studies. It has helped very lot, so that will give us to select some of the project work for the students like that, sir. I am very much happy, and wish you all the best. Future also, if you conduct this type of program, definitely we will involve, sir. Thank you very much for each and every person who involved in this program. Thank you very much. Thank you.
Thank you, sir. Thank you for your valuable feedback.
Hello, sir.
Yes, sir. Ashok, sir.
Yes, sir. I'm Ashok Kumar, sir, from Walchand College of Institute of Technology, Solapur, sir. Working an assistant professor, specialized in transportation engineering. From past 4 days, I have seen right from start of the design of the concrete pavement. The Sudhakar Reddy sir explained the design of concrete pavement very well, and further all the design aspect, quality control aspects, and white topping topics, all are excellent. All resource persons were explained very nicely. I really thank all RGUKT Civil Department team for their continuous effort to bringing this course, FDP course. I'm looking forward to attend more courses from your side, sir. Thank you, and thank you for whole team, sir. Thank you so much, sir.
Thank you, sir. Thanks a lot, sir. Anyone from the participants?
Yes, sir. Hello.
Yes, sir. You are audible, sir. Sudhir, sir.
Yeah. Yes, sir. This is Sudhir Gaike. I am from Sanjeevani College of Engineering, Maharashtra. I first like to thank the organizer and congratulate Dr. Amarendra sir and his team for organizing this successful event from first day to this particular last day. And I am from Holy Shrine of Shirdi Sai Baba. Shirdi Sai Baba airport is nearly 8 kilometers from this particular institute. So I will like to invite all the participants and organizers of this event. If you are approaching or you are coming from this particular location of Maharashtra, Ahmednagar district, please try to feel free to contact me, and the help I will render if possible from my particular side. I am once again thankful to all the experts from IITs, NITs for their valuable words regarding this particular session. Sir, please provide my number. The help, if I am possible, that will be given if you are coming towards Maharashtra State or Shirdi Sai Baba. Thank you, sir.
Thank you, sir. Thank you very much, and we are very grateful to your offer, sir.
Yes, sir.
Any other participant?
Good afternoon, everybody.
Good afternoon, sir.
Can I audible?
Yes, sir. Yes, sir. You are audible.
I'm Engineer Satyanand Sethi from Odisha. I am from Odisha Polytechnic Skill Development and Technical Education from Jharsuguda district. I really grateful to be a part of this session, and very useful, informative, and very practical based session. As we worked in the field, what are the necessary, what are the problems come out, and what are the problems we faced. It is actually really practical based, and problems, all the problem solution based topic has been discussed. So we really grateful to the organizing committee and all the dignitaries for making us a part of this. So thank you, and thank you all. If any future, any opportunity will be there for us, so kindly intimate us and be a part with us also, and our faculties with the organization. Thank you all.
Thank you, sir. We will definitely inform you, sir.
Yes, thank you.
Hello, this is Dr. S. Krishna Rao. Am I audible?
Yes, sir. Yes, sir. Yes, sir. You are audible.
Yeah, this is Dr. S. Krishna Rao, Professor and Head of...
How are you, sir? Krishna Rao, sir.
Very fine, sir. Sir, I'm Professor and Head of the Department of Vignan Bharat Institute of Technology, Civil Engineering Department, Hyderabad, sir. I just congratulate Dr. Amarendra, sir, and his team for organizing such a good webinar, FDP, wherein he blended academicians, researchers, and industry experts in the FDP. So, and he also brought one of the stalwarts of transportation engineering in India, Dr. Sudhakar Reddy from IIT Kharagpur. He delivered two wonderful sessions on the design of rigid pavements, sir. And most of the faculty members who have attended this FDP are benefited because sir was instrumental, Professor K.S. Reddy was instrumental in the development of the IRC 58 codal provisions. So I thank Amarendra sir to organize such a beautiful FDP. And one more thing is, he also invited young faculty members from IITs, IIT Madras, Surender Singh, Dr. Surender Singh, and IIT Tirupati, Krishna Prapurna Bilgiri. Those were youngsters in transportation engineering research as well as the teaching fraternity. So he invited those youngsters to this FDP, and they wonderfully shared their ideas as well as research interests to all the participants. That is the second thing Dr. Amarendra did. And third one is, he also invited the experts of the industry, like the retired Chief Engineer Bhavan Rao sir. I happened to work with Bhavan Rao sir in Vijayawada Municipal Corporation, where I asked several questions related to the practicals. So the Bhavan Rao sir explained very well about all my silly doubts as far as the construction activities are concerned. And also he invited one of the best expert as far as white toppings is concerned in India, from Ultratech Ramachandra sir, with respect to the white topping importance and so on. So I once again congratulate Amarendra sir for wonderfully organizing, and his team members, particularly Chaitanya, is wonderfully organized event with respect to his interaction with the participants, and also inviting the guests, and also concluding the remarks of each and every session. It was very wonderful, sir. I congratulate the entire team. I definitely participate in the coming events of all RGUKT civil engineering events. Thank you, sir. Thank you for giving me this opportunity, Dr. Amarendra.
Thank you, sir.
Good afternoon, sir. Can you hear me? Good
Yes,
afternoon.
sir. Yes, sir. Raghu Prasad, sir. You can speak.
Yes, sir. I am K.V. Raghav Prasad. I am an associate professor in the Department of Civil Engineering, sir, MBIT Bangalore. First of all, I would like to congratulate your team for the successful conduction of this 5-day FDP program. Like last month, I attended Dr. Krishna Rao sir and Krishna. They have conducted a very, very useful workshop. I think this COVID time is one kind of blessing disguise. Actually, we should try to involve more and more students because most of the budding engineers, if they can learn from this, like stalwarts like Bhavana Rao sir, Sudhakar Reddy sir, and really Dr. Amarendra and your team, you have done an excellent job because rigid pavement, most of us in teaching, we will teach only flexible pavement, and in India we have most of the flexible pavement. Everybody is used to flexible pavements and rigid pavement, so many of us we are not that exposed, and you have included in your topic not only the stresses in the concrete pavement, stress busters like Sahaja Yoga and all you have included also. It was, I was surprised to see that. I think the whole purpose of conducting this workshop, I think as a participant, I can say that it's very useful. And you have provided the material which we can try to pass it on to our student community. And you have tried to share the YouTube videos also. And so many of them, Sudhakar Reddy sir, he has done in the last month also. But every day it's like a new thing. Dr. Ramchandra, I invited in 2011 when I conducted the ACT seminar. But still today I feel every day that Aishwarya Rai and Elephant, he has given the practically how he talks, Bhavana Rao step-by-step explanation. See, we are all really fortunate that in this time of COVID time also, we are fortunate to hear all of them. And especially I think we can try to pass on this to our students because ultimately it should be like the stresses as we go down, we want to reduce the stresses in a pavement. We want to increase the output and we want to improve and increase the knowledge by spreading it to most of them. I think I congratulate all of you and all my namaskars to all the peers who are sitting here, and thank you. And we request your team to inform us in whatever the future activities you are conducting, and congratulations to you, and thank you one and all for giving me this chance. Thank you, sir.
Thank you, sir. We are allowing one more person, sir. Last feedback.
Hello, good afternoon. Myself,
Yes, sir.
Dr. Hanmanta. I must be very thankful to Dr. Amarendra and Ropas as the coordinators. First of all, they have selected a very good topic, and I was, though I am basically a geotechnical engineer, but still I attended all the sessions. I tried to understand my best the design of concrete pavements. All the lectures are really good. Dr. Yaskera beautifully explained all the sessions, how it was happened. And once again, I congratulate both the coordinators, Saravana as the head of the department, and Chaitanya, you really did a really good job. Okay, I was really happy that RGUKT-RK Valley has conducted a very good FDP. I congratulate the entire team and the civil engineering department of RGUKT. Thank you.
Thank you, sir.
Thank you very much, sir. Thank you very much for all the participants who has given valuable feedback, which will be taken up for the upcoming all the events. Now, I'm very happy to introduce Professor B. Sudhir Prem Kumar, Director of RK Valley Campus, RGUKT. Professor B. Sudhir Kumar has obtained Master of Engineering with a gold medal in Refrigeration and AC from Coimbatore Institute of Technology under Bardiyar University, and PhD in IC Engines from JNTU Hyderabad. He is having a total of 29 years of teaching experience and served various administrative positions. He is also working as a Secretary of Andhra Pradesh State Council of Higher Education. He has published 3 textbooks and substantial number of papers in national, international journals and conferences. He also has guided 12 PhD scholars and currently guiding 11 scholars for their doctoral research. With this short introduction, I request Professor B. Sudhir Prem Kumar to address the participants.
So, thank you, Saravana Garu, the head of the department. Respected Chancellor Sir, Honorable Chancellor Sir, Professor Kesari Garu, the coordinators Dr. Amarendra and Sri Rufus Garu, Head of the Department Sri Sarvana Garu, AO, FO and all other faculty and the experts who are part of this say 5-day FDP program and all the participants all over India. Good afternoon everyone. It is indeed a privilege for me to invite you to this function, valedictory function, where our Honorable Chancellor Sir is also taking part as the chief guest. We, the RGUKT, are really working under the able guidance of our Chancellor Sir, who is the visionary and who got lot of experience in the field of education, and we are moving forward under his able guidance. We also remember the services and the efforts made by our Honorable Vice Chancellor Garu, Professor K. Hemachandra Reddy Garu, who is away from the valedictory function. And also, I want to thank all my officers who are really involving in this 5-day FDP program organized by the Civil Engineering Department on recent advances in concrete pavements. I am sure all the delegates who are really taking part from all over India, you are blessed with rich experience of the speakers who are basically the retired chief engineer of R&B, Dr. Bhavana Rao Garu, and different professors from IITs all over India. I am sure all of you are really richly blessed with the experiences and their say lectures, including the video presentations. And that's what actually I could able to understand from the statements or maybe the sharing of the delegates. So on behalf of RGUKT-RK Valley, I want to thank the coordinators who has taken the care or who has taken the pain of arranging this, and I am sure this will be a really a commendable say maybe step taken by them, and I am sure all other departments and other faculty also will proceed in this direction by organizing many more number of webinars like this in all our departments. And I am sure not only from the director's point of view, I am sure from the administration, I assure all my faculty also, there will be full support, particularly for the academic events like this. And I want to invite all the participants who are say involving or say interacting all over India, welcome to visit our RGUKT-RK Valley, which is going to be having a beautiful say weather, academic say atmosphere, and many more other say such things where you can really enjoy the presence of beautiful sceneries in RK Valley. So I invite all the say participants and including speakers from IITs and others also to visit our campus. Maybe your presence will be richly blessed to our students also. Very good academic inputs, and they are reaching very good heights not only in India but also in abroad. So with this, I want to thank the organizers for giving me this opportunity and congratulate the Department of Civil Engineering for having a prestigious webinar like this. And also I seek the permission from Honorable Chancellor Sir to proceed further, and I request his maybe presence and his say involvement. Thank you one and all, sir. Thank you one and all.
Thank you very much, sir. And now I am very glad to reintroduce the guest of honor, Engineer D.V. Bhavana Rao, retired Chief Engineer, Roads and Buildings Department of Andhra Pradesh. Engineer D.V. Bhavana Rao is a fellow of Institute of Engineers, having 33 years of experience in various cadres and retired as Chief Engineer R&D. He has plenty of experience as consultant engineer and a quality auditor as well. He has delivered a number of lectures in national seminars related to road construction and educated department engineers to practice a quality road construction by conducting several workshops to them. With this short reintroduction, I request Engineer D.V. Bhavana Rao Garu to speak few words to the participants. Thank you.
Good afternoon, everybody. Good afternoon, Chancellor sir.
Sir, please unmute your mic, sir.
Good afternoon, Chancellor sir. Good afternoon, everybody. Actually, I was Chief Engineer at the time of foundation stone for the this Idupalupaya IIIT. Am I audible?
Yes, sir. Yes, sir.
Audible. Please go ahead.
Actually, every day we used to go to KCRED's chamber to finalize the designs and plans. Regularly we used to meet, and Honorable CM fixed a timeline taking up these utilities at one is at Idupalupaya and Basra and Nosewade. A lot of pressure was exerted on us, and we are successfully finalized the designs, drawings, and laid foundation stone at Idupalupaya and completed up to basement. Afterwards, I was transferred to R&B department. That's why I had a course. I regularly used to meet K.C. Reddy sir. And Raj Reddy sir was there also. And Ashutosh Misra, IAS officer, was there. Again, I am very glad to give a presentation for the RGUKT Faculty Development Program. Yes, this program is very well organized. Regarding the result payments, every minute aspect was covered in this program. I think the participants must be benefited, and everyone will serve the regarding the improvement of quality. Also, they will definitely educate the students also with such programs. I would use such programs and different subjects also shall be conducted at least every 3 months. One FDP, at least 3 months or 6 months, one FDP shall be conducted for such programs shall be conducted, and different subjects also. It makes the teachers teachers' knowledge is improved. Simultaneously, it improves the knowledge of the students also. I thank the organizers for giving me this opportunity to participate in the FDP program and this valedictory function also. I thank Amarendra and his team. Congratulate Amarendra and his team for conducting it very well. Thank you very much.
Thank you, sir. Now I take privilege to introduce Sir, excuse me for a while. Chancellor sir will join the meeting. Till then, we'll wait for a minute. Hello all. Just please wait for a while, as there is a technical issue with the Chancellor of RGUKT. He will join in a while, in few minutes. Thank you. Sir, welcome back, sir. Now, I take privilege to introduce the chief guest of this function, Professor K.C. Reddy, Honorable Chancellor of RGUKT. Professor K.C. Reddy has a doctorate in economics and taught at Andhra University for over 3 decades. He has acclaimed as a teacher and researcher par excellence by his
Not
students
required,
and peers.
not required. No,
Sir,
no,
sir. Yes,
no
sir.
introduction.
Yeah, okay. Sir, with this, I request
I'm sorry
Chancellor
for
to.
captivating and Sudhir, Dr. Amarendra, Dr. Rupas, Dr. Sharvana, and Dr. Bhavan Rao Garu, all the other very learned guest speakers, participants at the 5-day faculty development program in concrete mixture. I'm personally happy that Dr. Amarendra and Dr. Rupas have taken the initiative, and this initiative is contributing to something that people are taking back when they go back to their universities, colleges. That's something that is tangible, something that can be grounded, something that they will do for the usefulness of the community. I need not emphasize the importance of number one, highways. Number two, in the modern era, when transportation is increasing, the pavements have also become extremely critical. If you look at the smart cities around the world, in India in particular, well, in every smart city, the pavements have become extremely important. sometimes, to say in a very lighter way, the pavements have become more important than the highways, than the roads itself. I'm saying it on the basis of my own experience in Visakhapatnam. The earlier, there was a 60 feet road. Now 2 ways they have developed pavements, each measuring about 7 feet. So 14 feet is taken away towards pavement. With the result, the road itself has become narrow. Why I am mentioning this is because societies that have progressed fast internationally, and countries that they have done very well, and cities that have made remarkable progress, they have all focused on highways, and highways with all facilities for payment. Why we talk about payments in India today? If you make a comparison of what is there in the Western countries and what is there in India, if somebody is walking in Washington or in Chicago, or for that matter in Beijing or any city, England, then the walker is given priority. The person walking is given priority by everybody who is driving either a two-wheeler or a four-wheeler. Well, that way, I think we have lost the importance of the walker and the pavement. This is one point. The second and equally important thing is that when you are designing concrete mixtures, well, that's where technology becomes extremely critical. I think Dr. Bhavan Rao Garu, with his rich experience in engineering and practical engineering, has not been teaching theory, but then putting theory into practice. That's what exactly I think this workshop must have made you to learn. Now you need to look at the quality of the soil. The quality of the soil, the uniqueness of the soil required what I would say a unique concrete mixture. You can't say that in a hard rocky soil, the kind of mixture that you use is equally good in what we call the land, which is alluvial and then largely a loose soil. That's where I think the upland areas on the one side, the coastal areas on the other side, the tribal areas differently, they require different kind of quality mixtures. Now, why we keep on doing the highways every year, the maintenance is going, and why in the rest of the world, once a highway is laid, once a pavement is developed, well, for at least 25 to 30 years, they don't look back to that. The reason is they design it, they do a lot of homework, they spend money on R&D. They also think in terms that they don't sacrifice on the quality. They compromise on quality. Now, this is what engineering in India particularly do take care. Now, we are spending a lot of money on highways and development of pavements, and it is the right time for this kind of a workshop. I again congratulate my friends, colleagues who have taken the trouble. I think all of you in a pandemic situation, otherwise you should have seen the physical beauty of RK Valley campus. Maybe you will come one day to RK Valley, enjoy the scenic beauty of the campus, apart from the intellectual contributions that our young faculty are making in the field of civil engineering in particular. I think civil engineering over the years, there was a point of time Well, engineering was nothing but civil engineering. I think during my age, the student days, most of the brilliant people were going to civil engineering. When Nagarjuna Sagar project was built, well, there was a terrible shortage of civil engineers. And even people, they used to discontinue their engineering program and join as engineers, and diplomas were there. Now, those were the days. Then after some time, there was slump. There was no demand. There were no takers for civil engineering. Now again, with the development of so many projects, highways, irrigation projects, there is again a sea change. But then we need to look at the use of technology in civil engineering. The civil engineering of today is entirely different from the civil engineering of 50s, 60s, or even 70s for that matter. So you need to update yourself. That's in that perspective, if you look at the faculty development program, certainly it is something that is badly needed. I'm particularly happy that Atal Academy has given us this wonderful opportunity, and my colleagues have seized that opportunity to organize this program beautifully. I thank them again, and I personally congratulate all the participants, thank them. If there were any inadequacies, we all own them collectively, and we will certainly. I thought some of the faculty, the participants, when in their feedback, will tell us two things instead of all the way praising us. One, are there any shortcomings, inadequacies, gaps? The second is, what is it that they are taking back home, basing on the FDP? Now, any program, any workshop, any research today must be outcome based. I'm particularly happy that Dr. Amarendra, when he designed it, kept that in mind, and it is an outcome based FDP program. I'm happy. Thank you. Congratulate you. All the best to you.
Thank you very much, sir.
Thank you, sir.
With your guidance and support, we would conduct similar kind of programs in the upcoming days, sir. Thank you, sir.
Go ahead.
Sir,
go ahead.
Now I request the co-coordinator of FDP, Mr. Rupas Kumar, convey vote of thanks.
Thank you, Saravana. Respected dignitaries, Professor K. Reddy Garu, Honorable Chancellor RGUKT, Sri D.V. Bhagavana Rao Garu, Retired Chief Engineer R&B, Government of Andhra Pradesh, Professor Sudhir Prem Kumar, Director RGUKT-RK Valley, Dr. Amarendra Kumar Sandra, Associate Professor RGUKT and Coordinator of the FDP, RGUKT-RK Valley Administrative Members, Administrative Officer, Dean Academics, Finance Officer, Faculty Colleagues, my dear participants, a good afternoon to you all. Firstly, I'd like to thank the nodal officers and the representatives of AICT and Atal Academy for their approval and sponsorship to the program conducted by the Department of Civil Engineering, RGUKT-RK Valley. We'd like to convey our sincere thanks to the eminent persons who have agreed to deliver lecture sessions on the recent advances on the concrete pavement from both academia and industry. Professor K. Sudhakar Reddy Garu from IIT Kharagpur, Dr. Dharamveer Singh from IIT Bombay, Dr. Swati Maitra from IIT Kharagpur, Dr. Krishna Prapurna from IIT Tirupati, Dr. Surendra Singh from IIT Madras, Sri D.V. Bhavana Rao Garu, Retired Chief Engineer R&B Department, Government of Andhra Pradesh, Dr. Ramchandra from Ultratech India Private Limited, R. Nagendra Garu from Student Technoclinic Private Limited, Bangalore, Suresh Raju Garu from Samarth Infra Engineering Technocrats Private Limited, and Santosh from Student India Technoclinic Private Limited. And apart from all these technical sessions, 2 sessions were conducted by Mr. Amit and Mr. Chandrakant on Sahaja Yoga meditation. I thankful to you all the eminent speakers and the resource persons. I'd like to thank the RGUKT administration, Professor K. Reddy Garu, Professor Sudhir Prem Kumar sir, Mr. Mohan Krishna, Administrative Officer, Dr. Ramesh, Dean Academics, B.V. Sudhakar Reddy, Finance Officer, and the faculty members of Civil Engineering, Mr. Chaitanya, Mr. Saravana Kumar, for their support in organizing the lecture session. I'd like to convey my sincere thanks, Mr. Lingamurthy, software engineer, Mr. Govardhan, IT faculty, and other IT supporting staff, Mr. Mani and Mr. Chetri. With all your support, the program has been executed effectively without a minor issue, surpassing the limitations of ICT-based teaching, and for making necessary arrangements for live streaming to our students. Thank you one and all for your support. I also thank the participants for their patience, sincerity, and cooperation in these 5 days. As mentioned by some of the professors in their lecture sessions, we, the faculty from the Department of Civil Engineering, are working closely with the institutes such as IIT Tirupati and IIT Madras and developing collaborative projects. With the support of RGUKT administration, the Department of Civil Engineering, RK Valley, is also planning to work with the National Highway Authority of India, NHAI, to examine and monitor the national highways intersecting Kadapa city in Andhra Pradesh, which is expected to start within a month. Overall, I'd like to say that many more programs and projects which are of interesting are in the pipeline, and this program is just an inception. Please do stay in the touch to get involved in such kind of projects. Being a budding university, we always look for collaboration and co-action from the faculty members and organizations across the country to establish strong academic industrial relations and to achieve high research quality outputs. As the program coordinator, Dr. Amrendra Kumar Sandra has mentioned, one more faculty development program is proposed on bituminous pavements, and hopefully it will be approved within the next 2-3 months by AICTE. And we wish that we'll meet again in our campus. And thanks for your time, thanks for your patience and cooperation in these 5 days. I thank all the participants. Thank you so much.
Thank you, Rupas.
Thank you, Rupas Kumar. And now I would say that no learning goes without test. So now I request Chaitanya to organize the testing of this FDP. I'm very thankful to the Chancellor of RGUKT, Professor K.C. Reddy Garu, to make this program a grand success by joining and giving his insights. And I thank Engineer D.V. Bhavanarao sir to grace this and to participate and grace this occasion. Thank you all. And please wait for the test to be uploaded, and the link will be given. Dear participants, you are taking up exam. So after clicking on login, successful login. So please click on available courses. Then you will be able to see that there is a cement concrete pavement test.
Yes, I see. So please click on start, attend the exam. Then you will could able to see that all the 50 questions on the right side. Then you will be given the time of 50 minutes.
ఎన్ని గంటలకు పని చేయాలా ఏంటంటే ఏం చెప్పారు బా ఏదా అది మీ ఓడే పెట్టుకుంటా అన్నాడు. నేను చెప్పిన అర్థం చేసుకో.